Greetings and warm welcome. Let's have another day of learning, another lecture. So let's discuss in this lecture about the scope and the importance of ratios. So let's recall and let's reinforce our learnings on the simple topic like ratios, which is going to be used in our future applications on time, speed, distance, and time and work. So keeping that in mind, of course, not only ratios, we will also talk about proportions and variations in this particular lecture. So let's get started. Let's get started on this note. So let's understand that, okay, it's a pretty simple lecture as I informed you. Therefore, it's more of a recall from your high school that I'm trying to do maybe from the primary and the high school. That's where you learn most of the ratios and its application. Let's quickly go ahead and try and recall them, try and reinforce those learnings. Let's try and see are there any approaches, are there certain things that you got to kind of remember as you go along this particular journey. Let's go here. Let's get started on this note. Get started. The agenda is huge, as you could see. All right, I listed complete one page of things. All right, now one complete slide of things. What are the things that we are going to do under the ratios? Right, it could be under the ratios, or it could be under the proportions, and also it could be under the variations. Right, now these are the things that we are going to consider and discuss. But let's not bother too much about the names, but let's try and see. All right, now so how, as we go along, let's try and explore those things as we go along. Let's not panic about the names out here. So names might always sound a little unfamiliar, but as we go to the approaches through practicals, we'll be able to understand what is the relevance and the importance of this. So here we go, friends. Let's get started here. Here we go. Here we go. So firstly, let's understand that what we can compare. Ratio is about comparison, right? Ratio is about comparison. Just like the percentages were about comparison, ratio is also comparison of like things. Ratio is also a comparison of like things. And generally, we write the ratio in its most simplified form, right? Most simplified form in the sense like I don't generally write the ratio of A and B. Generally, we don't write the ratio of A and B as 4:2. Rather, we write it in its most simplified form saying that, hey, the ratio is 2:1. Right, we abstain, we stay away from writing it as 4:2. We generally express it in the most simplified form. Right now, is writing 4:2 wrong? I didn't mean that. It's not wrong, but it's not a correct practice. That's all I meant. So correct practice. Therefore, can I see it 4:2? Should I discard it? All right, if I see 4:2, don't discard it. It's not a right practice. That is it. All right, fine. 2:1, that's a simplified form of writing the things. Now, as I said, all right, now they're abstract in nature. What do you meant? No units, because you're comparing the like things. Assume that you are comparing the heights of two things, like things. You are comparing the height of person A and person B. You said that one person is 5 feet tall and the other person is 6 feet tall. 5 feet tall and 6 feet tall. Therefore, you could say that, man, the ratio is going to be 5:6. The units get cancelled. Well, ratio is what? Something divided by something. When I talk about ratio of A is to B, mathematically, what does it mean? A by B. Therefore, for A, there is a 5 feet here. All in place of A, we're writing it as 5 feet. Well, at B, you are considering it as 6 feet. Therefore, what happens? Feet get cancelled, but 5 and 6 cannot be further simplified further. Therefore, you say that the ratio of the heights of two people A and B is in the form 5:6. Always the first number corresponds to the first person. If you're writing a sentence along, the ratio of the heights of A and B. Now look at this. You came across person A name first, A and then B. Then while writing the ratio, remember the first number that you write is always about A, and the second number corresponds to B. There is an order. All right, let's not forget the point that, okay, there is an orderliness when we represent a ratio. Hey, can I have ABC? Of course, yes, you can have ABC. But when you write those numbers, if without the word respectively, there is an orderliness when you write the ratio. It goes with the way you mention those names. If you mention A first, all right, if you mention A first, and then you mention C, and then you mention B, all right, in that order, and then you're writing the numbers as 2:3:4, you mean that, hey, A corresponds to 2, C corresponds to 3, all right, and then B corresponds to 4. The word respectively is not required. Ratio is considered to be in the order. The words are taken in the order. The words and the numbers are taken in that particular order. Let's keep that in mind. Orderliness is something that you should not forget. And because it's in the simplified form, when we know that, when we say that, hey, A is to B are in the ratio 5:6, does that necessarily mean that A should be 5 units and B should be 6 units? Of course not. All right, because it's in the simplified form. It could as well be 10 and 12 units. What did you do? I doubled both the numbers. It could as well be, all right, now the 15 and 18 units. What did I do? I tripled these particular numbers. Therefore, how do you represent in the generic form? Therefore, you would say that, man, A is equivalent of 5x. You look at this 5 and you say that A should be equivalent of 5x and B should be equivalent of 6x. All right, b should be equivalent of 6x. Right, now let's keep these things in mind. These are pretty elementary things. First 10-15 minutes I'll talk pretty elementary that you study in the primary before you get onto the high school. All right, let me remind you of those things when I start with this. Okay, very simple question given in the primary school, maybe class 6, class 7. Pretty important, pretty preliminary question. 2x plus 3y divided by 2x minus 3y is 7 by 3. Find x is to y. All right, find x is to y. Sure, we know the cross multiplication, etc., etc. Not a worry on this. Right, x already, can I cross multiply them? Yes, already you can cross multiply. Already you would rather say that, okay, I multiply this with this, I multiply this with this, I bring them together, and I'm going to solve this. Fair, that is one method of this. Also, the teachers would have said that, hey, look, all it now, so divide both numerator and denominator by y. That's a classic method you learn in the school. I just want you to be aware of it. That's my whole point here. What did you do? All right, you have 2x plus 3y, all right, divided by 2x minus 3y. Let's go back to the school at once for once. Right, I'm not really interested in solving this question. I'm interested in helping you to recall what you learned in class 6. How did you do this? All right, when this was given to me as 7 by 3, all right, how did I learn to work with this particular question? You said that, hey, divide both numerator and denominator by y. That's how you learned. That's how you learned. In some critical problems, when you put it as a part of algebra, which I've already talked about that in the quadratic equation, it becomes very important. Such techniques are important. From that perspective, I'm doing this question. Okay, divide both numerator and denominator by y. Therefore, the result does not change by dividing both numerator and denominator. How does it look like? 2 divided by x plus y, x by y, plus 3 because y by y is 1. Whole of this divided by 2 divided by x by y minus 3 is equal to 7 by 3. Already you learn to write this first. There is nothing wrong, but this is the actual approach for it. You get the marks in class 6. If you do something else, you will not get marks, right? Yeah. So that's the whole idea. Now cross multiply at this stage. Already you consider this, then you cross multiply, not before this. Therefore, you will say that, hey, 6 times of x by y. I'm cross multiplying, friends. 6 times of x by y plus 9 is also equal to 14 times of x by y minus 21. What did I do? I just cross multiplied both the stuff. Therefore, you will say that 8 times of x by y, simplify. 8 times of x by y is also nothing but 30. And therefore, what is x by y? Simplify this. It becomes 15 divided by 4. All right, simple result. Hey, can I cross multiply right here? Absolutely, there is no problem. And also, I'm sure, all right, now those who are kind of all right well versed with algebra, looking at this, all right, looking at these elements only with a sign change, I know that, okay, something all right now lingering in your mind, something is all right now, something is popping up in your mind. It's saying that, hey, can I also use component or dividendo? Fine, refrain for now, refrain those thoughts. Let's refrain from those thoughts. Component or dividendo, pure algebraic expression of doing these things. We'll think of it later. We'll think of it later. Right now, so because this also reminds you, because only a sign change, right? There is just a sign change. Whenever you have the same elements, 2x and 2x. So here you have 2x, here you have 2x. There is a 3y and 3y. What is it reminding you about? All right, just in case, all right, your memory is fresh. All right, just in case, it's reminding you about component or dividend, if I'm not wrong. We'll go there at a later stage or in some other lecture. Should not be a worry. But the point is, let's get acclimatized, let's get adjusted, or let's get used to these ratios quickly. Second point, compounding of ratios. That's another thing that you learn, right? Compounding of ratio. So what you learned earlier is a common ratio. Now we are talking about the compounding of ratio. And what do you mean by compounding ratio? Compound ratio of the things. Now this is how you get, all right, now a by b is given to me. All right, it's given that a by b is 2 by 3. Perfect. All right, then it is also given to me that, all right, now let's call this as equation 1. It's also given to me that a b by c is equal to 4 by 5. Perfect. All right, now this is the equation 2. What do I do? Multiply both the sides. See, whenever you have two equations, you have a choice. Either you can multiply, you can add, you can subtract, or you can divide, right? Rather, let's multiply this time. Let's multiply the left hand sides, and also let's multiply the right hand sides. These are the left hand side, this is the right hand side. Let's multiply them. So what do you get? You get this as this, a by a into b, and then b into c. What did you do? You multiplied both the equations. Then you better multiply the other sides as well. You better multiply the other sides as well. Now this is called as compounding, which means getting the relationship of a by c. B gets cancelled. Getting the relationship of b by c is called as compounding of these particular ratios. This is called as the issue of compounding. Great. So what is the other way to deal with this? Listen to me carefully, all of you. Listen to me carefully. Other way to deal with this. This one way. This is one way that you learned in the primary school, class 7 maybe. Right. The other way is what? So you write this as a is to b. A is to B. Now, because you stopped with B, you better start with B. Yeah, already you better start with B. Continue that thread. My point is continue with this thread. Second one, you write it as B is to C. Great. Now, write the numbers corresponding to A is to B. What is A is to B, friends? 2 is to 3 here in this problem. What is B is to C? It is 4 is to 5. It is 4 is to 5. Now listen, if you follow this trend, that is what? If you conclude with B, the first line, then start with B, the second line. If you do that, the compounding of the ratios, A is to B, and if you want the relationship of A is to B, that can be obtained as multiplying the first row, multiply the first column for the value of A, that is 2 into 4, write it under this, that gives you A. Okay, then multiply the second column, all right, the values in the second column, that gives the relationship of C. All right, therefore 3 into 5, that is 15. All right, now same thing, whatever you did, A by C, that is A is to C is 8 by 15. You get that part. Pretty direct. All right, pretty direct. All right, pretty direct. All right, now listen. What if I want A, B, and C, everything in this particular case? Let me rewrite it for you. A is to B is 2 is to 3. A is to B is 2 is to 3. Great. Then ensure that, okay, you start with B. All right, now that should be all right in that order. You stopped with B, the first information. Then you start the second information with B. Therefore, you are writing it as B is to C. What is B is to C, friends? It's 4 is to 5. All right, now let's say in this time I'm interested in A is to B is to C. Assume I'm interested in this entire thing, right? Not just A and C, because the compounding is more an issue of A and C. But assume that this time I'm interested in A, B, as well as C. How do I go about this? Now listen to me. So A, we already know that we got to multiply the first column. All right, we got to multiply the first column, that gives me the values of B. Perfect. Therefore you write it as 8. What about C? You got to multiply the values of the last column, that gives me the values of C. Perfect. Multiply them. 4 into 5 into 3, 15. You got that. A. What about B? You multiply the corresponding values of B, friends. All right, now here, this is the B which corresponds to, and this is the value of B which corresponds to, isn't it? All right, now that's where you wrote those numbers. So now what do? You multiply those values there. Now you say that, okay, I multiply these two. What is 4 into 3? That is 12. So therefore now you got the relationship of A, B, and C. Pretty simple one. All right, pretty simple one. Can be done mentally as you go along. But my point is, in the first 15-20 minutes, let me quickly remind you about the things, all right, now that you kind of did in the high school or primary school, which is very, very elementary, and it should be at your fingertips. Right now, this is what we write it as ABC. Let's extend this problem a little bit. Let's extend this. I hope all of you are with me on this. All right, I'm helping you to recall what you learned in the primary and high school. So let me extend this a little bit here as we go along. Right, all right, no worries. All right, now let's get on here. Let's get on to the application. I kind of helped you. Okay, let me extend this. Let me take this. All right, now let me take the same page. Let me extend these numbers a little bit. Probably going a little deeper might help you a little bit, because sometimes you get wonderful CAT questions simply built on having A, B, C, D, E kind of elements. So therefore, let me extend this problem. For you. Let's see how do we handle in that case. Okay, here we go. So AB is given, BC is given. Let me add an information to this. So CD, let me add an information to this. What if I also give the information on CD? C is to D. It's also given that C is to D. All right, C is to D is 3 is to 2. It's given that C is to D is 3 is to 4. Let me write it as 3 is to 4. C is to D is 3 is to 4, right? So now I'm interested in, hey, I want the relationship of A, B, C, D. Let me write the first information is A is to D. Let me change this. I want the relationship of A, D. And then I want complete relationship of A, B, C, D. Right? Complete relationship of A, B, C, D. Great. Now A and B is pretty simple proposition. Already A and B is a pretty simple proposition. A and D, the first one, is a pretty simple one. Put it in the order. A and B. Put in the order first. A and B. What's the relationship? A is to B is what? 2 is to 3. Good. So because you stopped with B, you better start with B. That's very, very important. That's very, very important. All right. Therefore, you are writing it as B is to C is what? 4 is to 5. Hey, you may wonder, hey, instead of giving B is to C, what this author would have given C is to B is equal to 5 is to 4. Both same, friends. Both same. All right. Now, author might have given it as C is to B. No problem. You write B is to C. He might have given C is to B is 5 is to 4. So what? You write B is to C as 5 is to 4, because you are writing in an order, just like an arrangement problem in puzzles arrangement. You want to arrange the things in an order so that you get to the result faster. That's the whole idea of this, so that you can get to the result faster. Right now, let author give all it at his own style, in his own style, but you rewrite them all it now to get that particular order. Great. All right, so you are learning this, right? B and C. Now what happened? You stopped at C, therefore you better start with C. Let's look at this information. So all right, therefore C is to D is in the ratio 3 is to 4. Perfect. So how do I get the relationship of A and D? Similar. All right, so similar. A is the first element, D is the last element. Multiply all the numbers in the first column, that gives the value of A. So if I just want A is to D here, I'm teaching you how. I just want A is to D here. Multiply the first column, that is 2 into 4 into 3. All right, that's what you're multiplying. All right, therefore that is 24. All right, that would become 24, right? Similarly, hey, what if how do I get the corresponding value of D? All right, because I know A now, how do I get the corresponding value? Multiply the similar fashion. 3 is to 4, 3 into 5 into 4, last column, just multiply the last column. All right, 3 into 5 into 4. So you will say that, okay, that is nothing but 60. You can simplify this, absolutely no worry. All right, you can simplify this. All right, you can simplify this because you understand that 12 is common between them. Therefore, 12 two times, like 12 two times and 12 five times. That's all right. After A is to D in its simplified form, because generally we give the ratio in its most simplified form. Therefore, it turns out like this. No worries. Now listen, I want A, B, C, D, entire stuff. How all four folks are related. A, B, C, and D. All how four folks are related. Now let's explore it little better. All right, let's explore it little better. Listen carefully here. Let me rewrite this information for you first. Let me rewrite this information. Okay, there we go. We have this. Right, A and D are already fixed. All right, I know A. So I need to fix C and D. I need to fix C and D. Now listen very, very carefully, right? Now listen very, very carefully. I'm adding a dimension to this problem. I'm adding a dimension to this problem, which is an important dimension. If you want to write your B and C values quickly, I'm adding a dimension to this problem. A and D, we are already clear. A and D, we are already clear. Now listen to me, friends. Listen to me. Where is A? A is here, the first element. Corresponds to 2. Now what you do, the first column is always downward. First column calculation is always downward. Keep it in mind. Okay, what is that downward means? I'll come to it. I'll come to it. Just keep it in mind. It's a mnemonic. Okay, first column A corresponds to 2 and it's always downward. The value of A is always downward. Perfect. Now look at D. Where is D, friends? All right, now here D. D corresponds to what? 4. So calculation wise, it's always upward. That is what you wrote. All right, that's what you wrote. 4 into 5 into 3. You did not count downward because there was nothing down there. All right, there was absolutely nothing down. Therefore, what did you do? You multiplied the number upward. Now look at the first column. When you wrote A as 2, what did you do? Did you multiply the numbers upward? Because there is no number upward. Therefore, what did you do? You multiplied the numbers downward. You multiply the numbers downward. Now listen to me. Right now, upward and downward, you listen to me. Remember those arrows. Now, where are B's? Now, where are B's? There are two B's here. Now, I'm teaching you how to calculate for B. All right, there are two B's here. Mark them. All right, now B is here and B is here. Now what does these arrows say? All right, this arrow says that count all the numbers downward. This arrow says count all the numbers upward. What does it mean? All right, count all the numbers, if any, above 3. Under this, count all the numbers below 4. Count all the numbers below 4. Why? You are already at this stage. These are the values corresponding to B. You have two values corresponding to B, and in the first column you got to multiply the numbers downward. In the second column you got to multiply the numbers upward, because those arrows, all right, those black arrows, now look at them, they're standing for downward and upward. Therefore, what I should be doing here, just multiply them, this into this, multiply all the numbers. Which are the numbers? 3 multiplied with 4 multiplied with this particular number 3. Just multiply them. 4 3 times 12, 12 to 3 times 36. You got the corresponding value of B. A we already know. A is 24 and D is 60, which we already know. I'm writing the B here. Let me teach you how to get it for C. Let me write the information separately. I guess all of you got this. If not, when I do for C, observe carefully, you get this particular value. A, B, B, C, C, D. I got to write the numbers in the order first. I got to put the numbers in the order. Right now, let me teach you for C. All right, we are doing on C. All right, we are interested in C. All right, where are the numbers correspond? Firstly, so you got to remember that this is always downward. All right, counting here is always upward, which means multiplying the numbers upward and downward. Great. Now, where are my C's here? My C is here. All right, this is my C and this is my C. Firstly, I need to multiply these two values for sure. So what is this? All numbers downward I should multiply. Here, all numbers upward I need to multiply. Downward, all right, now after this 3, downward, there is nothing, no issues. So multiply the numbers upward here. All right, now the upward of 5, there is another number 3. Multiply them, therefore 3 into 5 into 5. You are multiplying, therefore 3 into 5 into 5 into 5 into 3. Therefore, that becomes 45. Put them together. Now you know A, you know D. All right, you know how to calculate B, you know how to calculate C. See, I taught you how to do them in isolation as well. You just got to put them together. All right, therefore you say that, okay, what is A, B, C, D, friends? Therefore, this is 24. All right, now B value is 36. Put the corresponding values. C value is 45 and the D value is 60. We can simplify them. All right, we can simplify them once we have all these numbers. You understand that all these numbers are multiples of 3's. All right, therefore you can divide throughout by 3, which becomes the simplified form of this particular result. That should not be a challenge, but But how do you quickly write A, B, C, D? All right, that is something that you have learned in the high school, whichever the methods you guys would have learned. I taught you a method which is quick enough. In fact, if you understand this method, if you practice this method, it is pretty quick enough, all right, now to deal with this. Great. All right, that's about a little bit of compounding of ratios. Now let's go there. Hey, what if the ratios are not very convenient numbers? They're in the form of fractions. All right, what if the numbers look like fractions? Sure, we can convert to the integers. Now here we go. Let me take an example what I'm talking here. Now look at this, the ratio of ABC. All right, here there is a ratio of ABC here. All right, now author has expressed ABC. It's deliberate. All these are deliberate attempts. Hey, can't he write some nice numbers? Of course he can. Of course author can write some nice numbers. It's a deliberate attempt to check the concepts. It's a deliberate attempt. Okay, ABC are in the ratio 1 by 2, 2 by 3 and 3 by 4. Doesn't look nice to calculate. But find the share of B. All right, now so what happened there? There are three friends. 460 has been divided among them. So author is asking that what is the share of B? How many rupees should be given to B? The ratios in which they divided the money has been given out here. What is the concept here? LCM. Why? If there is a ratio, if I multiply throughout by a particular number, the ratio does not change. Think about it. Think about it, friends. Think about it. If there are three folks XYZ, I gave them the money in the ratio 1:2:3. Simple example I'm illustrating. I gave the money in the ratio 2:3:3. Okay. Then I revised those numbers. I said that, hey, this is 5:10:15. What did I do from here till here? Nothing. I multiplied throughout by 5. Did the ratio change? Absolutely not. It is not the simplified form. That's it. But did the ratio change? It did not change. By multiplying a given ratio by a constant value, the relationship between XYZ did not change. The relationship remained constant, right? Pretty similar here. Therefore, what do I do? All right, I look at the denominators. All right, in this case, what do? I look at the denominators here. Fine. So denominators are 2, 3, and 4. What do? I take the LCM. I take the LCM of these denominators and then I multiply the fractions by that LCM. Right, now that's where the concept of LCM comes here. Right, so what is the LCM of these particular numbers? Therefore 12. 12 is the LCM of these numbers, 2, 3, 4. Now what do? I multiply throughout by 12. In the sense, we had this relationship as 1:2, then we had 2:3. That's what we are giving ABC here, right? 3 by 4. Now this is what we are giving to ABC. This is what we are giving to ABC. What is that I'm talking here? So multiply all these numbers by 12. Therefore, you say that 12 into 1 by 2, 12 into 2 by 2. This is 12 into 3 by 4. All right, that's what you're doing. Simplify them. Therefore, you say that ABC are now in the ratio 6:8:2. All right, then you are saying that 9. 6:8:9. Okay, now this is the new relationship of ABC. In the sense, the given information, all right, now given information, so where author said ABC are in this ratio can be simply represented as this. Author could have done this job for you, but he says that no, I will not do it for you. You do it for yourself. All right, you do it for yourself. Great. All right, that's how you convert. Only keyword. What is the keyword? LCM. Just remember the keyword. If the numbers are fractions, if the ratios are expressed as fractions, and all right, now how do I convert it back to the natural numbers? How do I convert it back to the natural numbers or positive integers? Multiply by LCM, you convert it back. Great. So what does it mean, guys? Or just remember to always have a total. So what I meant, another important parameter when it comes to the numerical problem, A, B, C, and total. Just add total to it. All right, total to it, because this 460 is the total. Total to total can be compared. Hey, what does it mean? Now look at A here. What did you call for A? 6x. Because it will be 6x, or because it can't be 6. It's not that giving A is 6 rupees. No, 6x rupees. For every 6 rupees that you give to A, B should be given 8 rupees. But if you are giving 6x to A, then you should be giving 8x to B and 9x to C. Hey, what is the total therefore? Add them. Total means what? Add them. 6 plus 8 plus 9. You are adding those particular numbers, right? Which is becoming 23x. Which is becoming 23x. Always have this total in your mind. Or just, can I write it on the paper or should I keep it in the mind? Choice is yours. Choice is yours. But keep that in your mind. Okay, so 23x total distribution. I added these numbers, friends, right? I added these numbers, which has become 23x. Great. Now 23x value has been given to me as 460. Look, 23x implies 460. Therefore, 23x is equal to, implies means what? Nothing but is equal to. Or it is equal to 460 or implies 460. What is being asked? What is the value of B? A B is what? 8x is equal to what? Alright, therefore 8x implies what? 23x implies 460, then 8x implies what? Alright, now that is the question. I can either do it directly saying that okay, 23x implies 460, therefore 8x implies what? That is also fine, pretty fine. Alright, therefore you say that x is irrelevant, 23 20 times. Call it 20 times, therefore you say that okay, that's going to be 160. That's also fine. Some people solve and get the values here. I'm just showing you multiple approaches, what you learned in the high school, right? 23x is equal to 460, you write it, therefore x is equal to 20. Once you know x is equal to 20, you come back, you plug this number 8 into 20, which becomes 160. Either ways it is fine, either ways, whichever the way you calculate it is fine. But just remember that, okay, what is the point that we try to learn from here? Number one, so if the ratios are written as fractions, apply LCM and convert the fractions into integers. Convert them into integers. Also, whenever equating the total to the total, ensure that already you also have a dummy total in your mind. In the sense, you get the total in your mind and you find that variable, and then you tackle this problem further. Great, simple one, simple one. Alright, this is where you learn the ratios kind of. Okay, now let's go to one of the exam questions for us. Pretty simple one, no doubt. Alright, pretty simple one. Now this is the already first time. Now first we are entering into an exam kind of problem. So I will do 4 or 5 simple questions that came in the management entrance exams, including CAT. Alright, some of the simple questions. Right? Yeah, let's take a look at this first question out here. Alright, let's take a look at this particular question. 420 is divided into 4 parts such that half of the first part. Alright, now so read this question for yourself once. Quickly read this question for yourself. Yeah, good. All right, do it with me. Read it, do it with me. So equal, all right, they're all equal. What is equal? All right, now what are all equal? The 4 parts are equal. Not A is equal to B is equal to. He said that. All right, now 420 is divided into 4 parts. Let me call it as ABCD. Let me call it as ABCD. So what is the third part? Author is interested in what is C therefore, right? Now ABCD. Let me give names ABCD. What is the third part according to the author? C. All right, now because I gave some names to them. All right, ABCD. C is what I need to find out here. So simple question. Now look at that, how they are divided. Half of the first part. Now look, how do you write it? Half of A. Half of first part means what? Half of A, because you said that A is the first part. Great. 1/3 of the second part. How do you write? 1/3 of B. How do you write? 1/3 of B is equal to A. Why I'm writing equal to? Because all are equal. That's what he said towards the end. Look at that. Look at the closing of that particular sentence. How is he closing it? They are all equal. Therefore, I'm equating them. All right, do half of 1/3 of B. So next one, 1/4. All right, 1/4 of the third part. Perfect. 1/4 of C. 1/4 of third part, and 1/12 of the fourth part. Perfect. 1/12 of the fourth part. All right, 1/12 of the fourth part. Now what did he say? All these are equal. That's what I precisely did. All right, all these are equal. That's what he said, and that's what I precisely equated them to. I said that all right. All right, now so all right, now all these are kind of equal. Great. Now from here, now listen carefully, friends. If they're all equal, now A, B, C, D should be in the inverse form of these particular numbers. Didn't understand my statement? Assume for a moment the value of A is equal to 2. Value of A is equal to 2. Just write the inverse 1/2. 1/2. I'm asking you 1/2. All right, now so inverse of this, right? Now 1/2. What is the inverse of this? 1/2 inverse is 2/1. Okay, 1/3. What is the inverse of this? 3/1. Nothing but 3, right? Now so write the inverse for time being. What is 1/3? Consider the value of B to be 3. Now are they equal? Now just look so far. Are they equal? Of course, yes. 1/2 times of 2 is equal to 1. 1/3 times of 3 is equal to 1. All right, now they both have become equal. All right, now C. How do I write for C? 1/4 times of 4. Just write inverse of 1/4, friends. That's what I'm trying to tell you. Which also should be equal to 1/12 times of 12. In the sense, hereafter, when we are writing for the management entrance exam, equal is a very, very important word for us. If they say equal, half of something is equal to 1/3 of something is equal to 1/4 of something, very simple. Directly, I will write A, B, C, D are in the inverse ratio of those numbers. Inverse of 1/2, inverse of 1/3, inverse of 1/4, inverse of 1/12. I'll simply write them as inverse. So what is the inverse in this case? 2 is to 3 is to 4 is to 5. That's it. When I read this particular question, I would have immediately written this. See, that's what I proved here. A is nothing but 2. The value of corresponding value of B should be 3. Corresponding value, one of the values of C should be this. One of the values of D should be 12. Therefore, I wrote these corresponding values here. Sorry, not 5, 12. Right, 12. Great, all right, you got them. So as I told you again, total. Let's put it to total, friends. Put it to total, because total has been divided here. Total is 420. Therefore, what you're saying, A gets 2x, B gets 3x, C gets 4x, and this 4 gets 12x. Right now, therefore, you say that, hey, they are getting 21x. Totally, they are getting 21x. Hey, what does 21x corresponds to? 420. 21x corresponds to 420. Simple calculation, right? 21x corresponds to 420. Therefore, you can find the value of x. I mean, equate it, you get the value of x. Value of x is nothing but 20. Value of x is nothing but 20. Therefore, all it now go back and find out what is the value of c. Value of c, put x is equal to 20. All it 4 into 20, which results in 80, which is the required answer. Simple. What is the learning from this particular slide? What is the learning from this particular question? Simple. Whenever it is represented as equal, equal is all of them are equal. It's a very important word for us. Half of a is equal to 1/3 of b is equal to 1/4 of c, something given like this. Quickly write them as inverses. Therefore, a b c d, the ratio of a b c d will be the inverse of these particular ratios. It will be simply the inverse of these ratios. I hope you got my point. I hope you got my point. Good. If you have got my point, here is a question for you which I want you to solve. Right, here is a question which I want you to solve. Here is a question for you. If you have got my point, I'll give a minute. Solve this. Well, guys, all right, pretty similar to what we've been discussing. Very similar to what we have discussed here. Right, let's see that all 7,300 members are there in that particular troop. Or yeah, that's a group. Then 4 battalions, divided them into 4 parts. How did they divide it? Looks pretty large parts. All right, yeah, he said that half of the first, again the word is there. All right, number of men composed of all this. All right, 4 battalions, so that half of the first, this followed in the fourth, all comprised of the same number of men. Same, the word is first is the same. Equal is important there. Equal, he didn't say that all 4 battalions are equal. Half of first is equal to, that's how he said. All right, therefore all right, let's say that the 4 battalions are named as ABCD. All right, 4 battalions are named as ABCD. His question is, can you tell me the value of B, second battalion? How many men? How many how many people are there? How many soldiers are there in the second battalion? Great. So how do you write it? You write it as ABCD. So okay, not ABCD. You say that half of A. Let me write it, friends. Half of A is also equal to 2/3 of the second, that is 2 by 3 times of B, which is also equal to 3/4 of the third, that is 3 by 4th of C, which is also equal to 4 by 5 times of the fourth, that is 4 by 5 times of D. What did I say? What did I ask you to do? I said that, hey, look, whenever you want A, B, C, D there, so they will be in the inverse ratio of the numbers already corresponding to them, that is A, B, C, D here. Already your A, B, C, D is nothing but inverse of this. For A, write the inverse of this, that is 2 by 1. For B, write the inverse of this, you got to write it as 3 by 2. The C, ratio of C, let C will be in the form 4 by 3. D would be in the form 5 by 4. This is the ratio of A is to B is to C is to D. So again, I came back, now I came back to the proposition where now I'm seeing the denominator, the ratio is not an integer. Great, if the ratio is not integer, take the LCM of the denominators. So what is the LCM, friends? Already you say that the LCM of what? LCM of 1, 2, 3, 4. Where is 1, 2, 3, 4? In the denominator of the fraction. In the denominator of the fraction, what is this? 12. Multiply throughout by 12. Multiply throughout by 12. In the sense you are saying that I multiply all these values by 12. You multiply all these values by 12. Great. So therefore you say that 24 is to 18 is to 16 is to, right? Then you are writing it as 15. Just add up these particular numbers. Say, what do you mean add up these particular numbers? Total A, B, C, D, and there is always a total. I told you. Well, let bring back the total, a total factor as well. That is 12x, 18x, 16x, and 15x, which essentially becomes 73x. Now author said that, look man, this 73x is related to 73x is nothing but 7300. You can get the value of x corresponding. X is nothing but 100. Great. If x is 100, the second battalion has how many people? 18x people. The battalion 2 has 18x people. Therefore 18 times of 100, which is nothing but 1800. The second battalion has 1800. right, folks. Simple. So quick, all right, you got to be quick, all right. Now learning these kind of small things you got to learn. This should be at your fingertips so that you simply don't waste time. These are typical exam questions what I'm solving. You will not waste time behind them. You quickly write them part. You look at these numbers and you'll quickly write the relationship of ABCD from here, right? You quickly write the relationship of this ABCD, and then you'll proceed and finish this problem within a minute or minute and a half, right? Now that's how you approach this particular question. Great. Let's go to the next one, friends. One more example on this. One more example on this. Do it with me now. Do it with me. There is another example. Let's do it together. 7,000. All right, now read it. Read it. I'll give 30 seconds. Read the question. Yeah, okay. They're all equal. Again, all right, I start. All right, whenever I apply this, how do I apply? I apply by saying that they're all equal. All right, here we start here. They are all equal. The fourth part, etc., are all equal. So what is equal here? Our author is saying again, divide into four parts. Now, because my third example is also has four parts. Now, don't think that okay, in the exam they always give four parts. Not necessarily. They give you three also, but four is more way vogue. That's in fashion. All right, four is something. All right, now the authors try keep giving it, but three also is given. It is not that okay, three they may not give. These are the exam questions. They always give four there. That's all right. All right. Now they generally they give four more often than not. Okay, four parts. I'll divide them into four parts. Say A, B, C, D. Let's say A, B, C, D. What's the value of the third part? Author is interested in A. Why don't you tell me the value of C? Great. Now go to the first part. Four parts such that twice the first part. All right, that's 2A. 2A. Thrice the second part. 3B. Four times the third part. 4C. Six times the fourth part. 6D. All right, now he says that they are all equal. I already put the equal to sign there. They are all equal. Therefore, what is the ratio of ABCD? Therefore, what would be the ratio of ABCD? Put the numbers in the inverse order. Put it in the inverse order. 1 by 2. 1 by 2. What about B? 1 by 3. 1 by 3. Whatever the coefficient you are seeing for these, all right, now ABCD, you got to put them in the reverse order. That's what you learned in the previous two examples, right? 1 by 4. So what is this? 1 by 6. All right, what is this? 1 by 6. Right, all right. So what do I do? Take LCM. Again, LCM is nothing but 12. LCM of these numbers is 12. Therefore, multiply throughout by 12. Or LCM is 12 here. LCM is 12. You are converting fraction to natural numbers. So, okay, 12 by 2, 6 is 2, 4 is 2, 3 is to 2. All right, that's what the numbers that you kind of wrote here. Well, you kind of, all right, these are the numbers that you wrote. Great. Find the value of the third part. I already said that I always consider one total, one more fellow. Put total to perspective always. All right, have that fellow also in mind, because what is given to me is total sum that is divided. That is 6x, 4x, 3x and 2x, which is 15x, corresponds to what? 7,500. Therefore, what is x? All right, x is nothing but 500. That x is nothing but 500. Great, x is nothing but 500. What is the value of the third part? 3 times of this. All right, therefore you say that okay, the third part is 1500. All right, third part is 1500. That's a value of C. All right, that's what he's asking. What is the third part? It is 1500. Great, friends. All right, now that's about this question. All right, that's about this technique. Let's go further. Let's explore further. Let's explore further as we go along. Look at this. It's a beautiful question, right? Now, so I can extend this little further when I go into the time, speed, distance chapter. I'll extend this little further when I go into the time, speed, distance chapter. Let's curtail that question. It's a time, speed, distance question, technically, when it was asked in cat-like exam. So now I curtail this question so that first we'll understand the importance of ratio in this question. Then we will talk a little more about it at a later stage, All right, that's because we need to understand further concepts of time, speed, distance to completely put this question in perspective, because some more elements need to be added to this. So I curtailed it. I took a part of that question to illustrate this point out here. Take 30 seconds, read this question. Everybody read this question. Just take 30 seconds. Read it. All right. So here we go. Now this is what we have. All right, we are talking about the speed of dog. Speed of what? Speed of dog and speed of cat. Let dog and cat. All right, let's put the data in perspective. What did he say here? Leaps. That's nothing but the jumps in a given time. So now by the time dog takes 3 leaps, the cat can take 4 leaps. Fair enough. All right, by the time it takes 3 leaps, this fellow is able to take 4 leaps. Perfect. All right, 4 leaps. Now listen to this, friends. Now listen to this. But all right, now this is leaps per second. So how do you represent this data? You can write this as leaps per unit time. What is the time? I don't know. Maybe second, maybe minute, all right, maybe few seconds. I don't know. Let leaps per unit time. In a sense, all right, I write that information direct as it is. Now listen. The second one is important. Here is my word equal is correct. All right. Anybody who understood my concept so far, cakewalk. I will say that 2 leaps of the dog. That is 2 leaps of the dog. 2 leaves of the dog are equal to 3 leaves of the cat. Therefore, what is dog and cat? What I should be writing? Inverse part. For dog, I should be writing 1 by 2. For cat, because whenever that equal comes, that's what we learned. For cat, what I should be writing? 1 by 3. I got to write them in the reverse order. Great. All right, now, therefore, all right, now, distance covered per leaf. That's what you are talking. What is that information? This green one. Distance covered per leaf. If you want to understand it, what is that you are writing there? All right, what is this 1 by 2 and 1 by 3 you are writing there? Yeah, how you got this 1 by 2? Because 2 leaves equal. The word is equal. Therefore, 1 by 2 and 1 by 3 you are going to write. Fair enough. All right, now, therefore, what is the distance? Already I multiply these two. I multiply these values. Yeah, what I get now? Look at this, leaps per the unit time and the distance per leap. If I multiply, that is when I get the speed. Leap and leap are getting cancelled. Distance by time. What is distance by time, friends? That is what is nothing but speed. See, you got to understand the question. That's also there. Or it is not that you are blindly writing something out there. Sure, this is the technique I taught you. The technique I taught you is put them as inverse, friends. Great. But while you're writing, you need to have a clarity that what is that numbers that you are writing. The numbers should have a meaning there, right? Now, numbers should have a meaning. Great. You wrote them, multiply therefore, just for multiply this part. 3 into 1 by 2, all right, 3 by 2 is 2. Multiply this, all right, 4 by 3. Great. Cross multiply, because all right, I'll not take this as the answer because I'm in the fraction form ratio. All right, find the ratio. All right, put in the nicer format, cross multiply these values. Therefore, you will say that, hey, this is nothing but 9 is to 8. That is the required answer. 9 is to 8. Therefore, what is the ratio? Dog and cat. You are saying that the ratios of the speeds are nothing but 9 is to 8. Pretty simple one. Look, this question could have been understood and done a little faster and better, provided you understand this issue of this equal, how I need to compare them, when I need to take them linearly. Now, look at the first line. You took it linear. All right, when you took this as inverse. All right, when you took linear, when you took inverse. You got to be very clear while you are reading those statements. If you are clear and clearly having a grip with the concept, you will write the numbers the way it has to be written. Thereby the calculation becomes very easy. You can close this issue in about a minute and a half, provided you understand the issue clearly there. Right, you understand the concept involved there clearly, when to write it linearly like this, when to write it inversely like this. Right now, see, the last 20 minutes I talked about that. When to write linearly, when to write inversely is what I illustrated in the last 30 minutes, if you see. So go back, if you didn't understand it again, please rewind at a later stage, and then now look back. If it is clear, great. We are poised to move further from here. Let's move further. All right, now I guess most of you are with me so far. So if you guys have any doubts, you can put it on the Telegram group. Join the Telegram group. Join the Telegram group and put your queries in the Telegram group. If you are watching it live, I will try and address them. I will try and address some of your queries. Great, here we go. Another example. Let's do some examples before we go on to the proportions and variations. Let's do a few, consider and write few examples. Little variations. A bit of variations so that we'll have a complete grip on understanding of the ratios. Okay, try it for a minute. Try it for a minute. Next 3-4 questions, I want you to try it for a minute each. Great, I guess you got through, right? Now let's do this. How many 1 rupee, 50 paise and this, all right? Now, so then finally your number is in terms of rupee here, all right? Ultimately is talking in rupee. Therefore, let me first convert everything to rupee because this seems to be in paise. All right, they are in paisa. Therefore, all right, let me convert because the issue seems to be in rupee. The amount total, I said that all right, now you got to consider. So 3 parameters I have. What is the first parameter? A, B, C. If I write it as first parameter, I have the currency in terms of a rupee. I have a currency in terms of 1 rupee. Good. All right, that's a value, right? Currency. So I have certain number of currency, all right, which are 0.5 rupees, all right, which are half a rupee. Half a rupee. This 50 paisa, friends. I'm writing it as a half a rupee. Great. All right, then I have certain currency, all right, in the form of, I'm calling it as C. It's a currency, all right, which is in the form of quarter rupee, 25 paisa. That's a quarter rupee. All right, rupees 1 by 4, quarter rupee. Hey, what about the quantity, friends? All right, now these are the denominations. What I'm writing here is the denomination. So what is that quantity there for? All right, I'm talking about the quantity. What is the quantity that I have out here? Quantity is 4 is to 5 is to 6, which means 4, 5 and 6. But technically when the quantity is 4 is to 5 is to 6, what do you mean right now? So what do we mean is 4x. All right, we'll come to that later. And therefore, what is the value that you are talking about? Amount. What is the amount that you are talking about? Using a only, you look at the amount. 1 into 4, 4 rupees. You will say that rupees 4. Great. Yeah, what is the amount with this? Half into 5, 2.5 rupees. All right, therefore rupees 2.5. Yeah, what about the third one? Quarter into 6, that becomes 1.5 rupees. That is 1.5 rupees. But this is not what I have. I have 32 rupees. Now, if you add this, this has become 6 rupees, my friends. All right, this has become 6 rupees here. Not 6, all right, this has become, all right, this has become 8 rupees. All right, this is all you have. But what you have here is 32 rupees. Right now, great. So therefore, what is missing? It's just a denomination. Quantity is where you write x, isn't it? Quantity is where you write this x. 4x, 5x, 6x. What I'm trying to say here is sometimes we need to be mindful where I have to, all right, where I have to put the, all right, where I have to put the variable. I can't put the variable here. Hey, 1 by 4x, 1 by 2x. No. All right, that's not the place where you keep that x. You need to be clear at times as to where am I putting that x there, right? 4x. Therefore, what you write here, the same x continues, and you added them technically. You added them, therefore 8x. Now, what is that you are trying to say? I said that, hey, please try and consider the total fellow. What is the total here? 32x. All right, therefore 8x is equal to 32. Therefore, what is x here, friends? 4. What is x here? 4. Where I know, therefore, what does he want? All right, what is the, all right, no, he said that how many coins are there? Great, I need to multiply all of them by 4. 4x, 5x, and 6x. What is the value of x here? 4. All right, value of x is nothing but 4. Therefore, multiply each term by 4. You get your response. All right, you multiply each term by 4. You get your response. Therefore, you say that for this 4 into 4, there are 16 coins of 1 rupee. 5 into 4, that is 20 coins of 5 rupees. 6 into 4, there are 24 coins of 6 rupees. Right now, that's a proposition. Pretty simple one. Idea of this question is what? Sometimes don't be confused where to write that x. Just be mindful, think about it, and write the x at the appropriate place. Right now, here it is a pretty simple example, looks pretty simple, but sometimes we get confused when we get into little deeper issues out there. Fair enough. Let's go further. One of the beautiful questions asked in the CAT long time back. Beautiful questions in many other exams as well. Already, in fact, already it has been used in UPSC kind of exams as well. It's a very beautiful question. The numbers keep changing. The scenario might remain same. The scenario, let's understand this. Take a minute. All of you take a minute. Read through. Yeah, let's understand the scenario out here. So what happened? All right, now three of them, all right, three of the travelers they met. All right, now three folks ABC met. All right, yeah, and then like they are hungry. All right, now they are hungry. They want to eat. So what I has? So A has 3 cakes. All right, A has 3 cakes. This is the scenario here. They met. A has 3 cakes. Cakes perspective. So number of cakes that they have. A has 3 cakes. What about B? B has 2 cakes. Right, B has 2 cakes. Right, and then so there is a C. All right, now C has no cakes, but he has rupees 50. C has rupees 50, but no cakes. All right, now C. What about C? Cakes perspective 0. Money perspective, yes, rupees 50. Perfect. Money perspective, yes, rupees 50. What about the cakes perspective? None. So look at the word there. All right, now equally. All right, they eat cakes equally, for which C pays rupees 50. All right, now in what is the amount paid by C to A? That's what I need to understand. Very popular answer that comes out is 30 rupees. People will divide 50 rupees in the ratio of this 3 and 2. Very popular answer. They'll simply divide it in the ratio of the cakes that they have brought. In the sense, they'll say that, okay, A should get 30 rupees and B should get 20 rupees. Why? Because he distributed 50 rupees. All right, 30 and 20. That's a very popular answer. All right, now that comes out. No, guys, you will not distribute the money in the ratio of what has been brought in. You will distribute the money in the ratio of contribution. See, how does C distribute? C thinks, what did A contribute to me? I will give money proportional to this. What did C contribute to me? I will give money proportional to this. That is how that's how C would be thinking. All right, now that's what they brought. Now look at this. So how much they consumed? First of all, let's assume that, hey, how much they consumed, each one of them consumed, because they consumed equally. The word is equally. Great. Hey, what is the total number of cakes that they have? 3 plus 2, 5 cakes. 3 plus 2, they have 5 cakes. Totally they have 5 cakes. What they are doing, they are consuming these 5 cakes equally. That is what author said. A, B, C consume these cakes equally, which means A consumes 5 by 3, B consumes 5 by 3, C consumes 5 by 3. That's what you mean by A, B, C consume cakes equally. They are consuming 5 by 3 each, right? C also consumes 5 by 3. They all consume 5 by 3. Good. Therefore, now look at this. A brought 3, but he consumed 5 by 3 by himself. All right, 5 by 3 by himself, because that's his share. All right, he consumed 5 by 3 out of that number 3. All right. Here, how about B? B consumed 5 by 3. All right, B consumed 5 by 3 of what he brought. He brought 2 cakes, but he consumed 5 by 3 cakes. All right, he consumed 5 by 3 cakes. Great. So therefore, what did they contribute? What did they contribute to C? Contribute to whom? What did they contribute to C? So what he contributed is he brought 3. He brought 3. He consumed 5 by 3. Therefore, what he contributed is 3 minus 5 by 3. That is what he contributed. That's what he contributed. Similarly, what did B contribute, friends? B contributed 2 minus 5 by 3. This is what B contributed. This is the ratio. This is what B contributed. The number of cakes contributed A and B. I wrote them in the bracket. In fact, C is going to give the money in the ratio of contribution, not in the what they brought. This is what they brought. These are the number of cakes he brought. He is not going to distribute. He is not going to fall for what they brought. He is going to distribute wisely in the ratio of what did they contribute. All right, great. So let's understand this. Okay, therefore, what is this here? All right, now this particular number. All right, now this becomes 4 by 3. All right, this becomes 4 by 3. What about the other number? 1 by 3. Now, what is the ratio of contribution, friends? 3 and 3 cancel. The ratio of contribution is 4 is to 1. All right, 4 is to 1. That's a ratio of contribution. If ratio of contribution is 4 is to 1, the 50 rupees is going to be divided. Rupees 50 is going to be divided among A and C, A and B. A and B in the ratio 4 is to 1. So, therefore, A gets 40 rupees. Therefore, A gets rupees 40 and B gets rupees 10. All right, B gets rupees 10. Simple. All right, now simple proposition. You got to understand that the money is not going to be distributed in the ratio of what they brought. Rather, they distribute in the ratio of what contributions made to C by A and B. Right, great. Simple point. Simple point. Distribute always in the ratio of contribution. You'll see much deeper questions solid now based on this as we go along. But let's first understand the word contribution there. Focus on the word contribution. That did most of the trick, most of the job for you. Once you learned how to write this, how to think and write this proposition, your job is done. Right? Your job is done. Great. Let's go further. Let's understand another concept here. Take a look at this question, all of you. Take a look at this question. Okay, yeah. So there is milk water solution, 739 ml milk water. It's a solution already, milk water solution. It's not a pure milk. And he has given the ratio. I said that ratio is always in the order milk water. Therefore, the first is milk, the second one is water, because first is milk, second one is water. There is always an orderliness in ratios, right? That's what we spoke about in the beginning of the lecture. So therefore, 7 is to 2. How much more water should be added? Now look at what is the constant part, friend. What is the unchanging part? The unchanging part is milk, isn't it? The unchanging part is going to be milk. Let's understand this. Then I'm going to the cat question in the next one, right? You need to first understand this point very clearly. Yeah, you need to understand this particular point. Great. All right. So now what is it says? It says, what is unchanging part here? The unchanging part is milk. So now look at that initial case. Now let's go to the initial case. Let's go to initial. So what is happening in the initial? There is a milk, there is a water, and there is a solution. What do you mean by solution? Milk and water together. Great. Now look at that. What was the milk there? 7 portions. What is the water there? 2 portions. I'm writing this, friends. 7 is to 2. Hey, what is the total therefore? 9 portions there. Well, therefore 9 portions there. Okay, but then what is that 9 portion corresponds to? 729 ml. That corresponds to 729 ml. Of course, there is an x. You can always write it as 7x. 2x, which is 9x, which is equal to 729. Look, all right, now, so how considerable the author is. He has given the same number, 7 is to 3. What is that? Milk and water. 7 is to 3. Perfect. All right, therefore, what is the final configuration? In the sense, you added water now. You added water to this. After adding water, what is your final configuration? This is 7. this is 3, therefore this is going to be 10. So beautiful thing is, what is not going to change here? The milk is not going to change. That's what you said, because what you are adding is water. Great. Earlier the number is 7x, therefore here also it is going to be 7x, because that's not going to change. The amount of milk in the solution is not going to change. The solution is going to change. The quantity of solution is going to change because you have added, therefore it's going to be more. It can't remain 729. It is definitely going to be more, no doubt about it, right? It's going to be more. So therefore what you are writing here, 7x, 3x, and therefore you are writing it as 10x. Great. All right, now so look at this. How much more water should be added? Hey, how much water you are adding, guys? All right, there is a 2x which is now becoming 3x. Therefore how much water you are adding? 1x. The water that you are adding is 1x quantity. So therefore what I need to get the x? How do I get the x from here? 9x corresponds to 729. Therefore x corresponds to 81. Solve it. X corresponds to 81. Therefore how much water did you add? 81. That's your answer. That's your answer. All right, that's your answer. You just have to get the value of x there. Right now, therefore, what is that? Focus on the unchanging part. Just focus on the unchanging part. That will do the trick for you. All right, that would do the trick for you. All right, let's go to the next one. Let's take a look at one. Very simple one. Nicely, author has built up this particular question, projected it 7x, 7x. He did not change. Therefore, the life has become easier. Sometimes that might change. Sometimes that might change. Let's see. All right, now what does it mean to us? Take a look at this question. Take a look at this question. Very popular question. One of the very popular question. Yeah, okay. So again, focus on the constant part here. So if you look at this, fresh grapes contain 90% water by weight, while the raisins, that's something the dry grapes, let's call it as a dry grape. Raisin is technically nothing but little dried out, call it to the process, dry grapes. We call it as a kind of a dry grapes, which means there is less water content. Dry grapes contain 20% water by weight. So what did not change? If you look at the grape, if you take a look at the grape, there are two propositions. All right, grape. Right now, one, all right, there is a water. Well, there is a water content, and the second one, there is a pulp content. Water and pulp. Pulp is what? Non-water, basically non-liquid. Alright, let me call it as a pulp. Already want to call it as a different name? Absolutely no problem. Call it as a non-water part. Alright, now the grape has two propositions. Through precipitation, you can separate the water. Alright, now if you know a little bit of chemistry, physics, right now you can say that, hey, how do I remove water? Precipitation, whichever the process that you take through. If you can separate it, you can separate it. Alright, water. Therefore, there is always a liquid part, and there is going to be a non-liquid part. Right? There are going to be, these are the two parts here. Fair enough on it. So look at the first case, initial case, friends. Look at initial case. Look at initial case. Hey, what is the water proposition there? Whatever that you started with the initial case. Well, the water is nothing but 90%. 90% of initial is going to be water. Let me write it as I. Let me write it as I. Initially it is I, because 90% of what? I, right? 90% of I, because 90% is abstract. You attach something better to that. 90% of I is water. Therefore, how much was the pulp? Because that's what is given to me. 90% is water. Therefore, what was the pulp? 10% is pulp. Pulp is going to be 10%. Okay, finally, which means after taking it through the process, through whichever the process that they are following. Now it is processed grapes, called as dry grapes. We processed it. Once you process it, it has 20% water by weight. It has 20% water by weight. Great. So 20% is water. Now look at this, 20% is the water. See, final product is also 100%. Whatever the final product, it has its own 100% weight, right? Now out of which 20% is water. Therefore, how much is non-water? Non-water is going to be 80%. Because f is one number, one full f. Out of this one full f, that is nothing but 100% is nothing but one full f. If 20% is water, how much is pulp? 80% is pulp. Now again, unchanging part. Now look at this. Did pulp change? Absolutely not. Did pulp change? Absolutely not. Whatever was the pulp you brought initially, it is the same pulp which is available even now. What got changed is the water. All right, you took it through some dehydration process. All right, the water is what? All right, now evaporation process, not dehydration. That's the wrong word. Evaporation process. Right now, therefore, water got changed. The pulp you did not burn. Hey, did you burn the pulp there? No, absolutely. You did not burn the pulp there. You only, all right, now you evaporated water through this process. Therefore, pulp is constant. How do you write it, friends? What is this 10% here? 10% of I is also equal to 80% of F Yeah, what is that F here? 80% of what? F, because you can't leave it hanging, that 80%. 80% of what? 80% of F. Didn't you get the ratio here? Absolutely, you got the ratio. I and F, you got this equal. That's what we were talking about, the equality part. The equal has come there. I and F are in the ratio is what? 8 is to 1. Already 8 is to 1, because you write them in the inverse ratio. You write it as 1 by 10 is to 1 by 80. Fine. When you simplify, what do you get? You get it as 80 is to 10. That is nothing but 8 is to 1. Hey, what is that you are trying to say? You are trying to say that initially, if you start with 8x, you end up with 1x. If you initially start off with 8x content, this is initial. Initially, if you start with 8x content, you'll be left with 1x content. All right, 1x content. Therefore, now what did he start with? Find the weight of the raisins produced from 48 kgs of fresh grapes, which means author said that hey, it is not 8, man, it is 48. 8x means 48. Therefore, what is going to be 1x, which means 8x is equal to 48. Therefore, x is nothing but 6. Well, x is nothing but 6. Therefore, 1x therefore is nothing but 6 kgs. You'll be left with 6 kgs of raisins. If you start with 48 kgs of fresh grapes, you end up with 6 kgs of raisin. What is the important point I was talking about? I was talking about again the word equal. So now sometimes, all right, now see, earlier we talked about the deliberately seeing the word equal. The word equal is seen deliberately. All right, for example, questions like this. All right, questions like this, where you see deliberately you see the word equal there. Or you see deliberately you see the word equal there here. All right, you deliberately see the word equal. So when you come to this particular question, all right, now these two questions that we did, all right, you don't see the word equal, but you know that hey, these are equal. All right, but you know that all right, these numbers were equal here. All right, these numbers were equal. All right, what I marked in the box. All right, these numbers were equal. Right, when you come to this particular example again, all right, you know that hey, these numbers were equal. In sense, sometimes it is direct. Sometimes in the application question, it is not direct. You know that they were equal. 10% of something was equal to 80% of this. Watch out for them. Watch out for them. Sometimes the authors are direct to express they are equal. Sometimes they are not direct to express that they are going to be equal. Right? Yeah, that's a little bit of very basic understanding of the ratios, where I spent about 55 to 60 minutes. Right? I spent about that time to illustrate all certain things that you got to kind of consider while you are working on the simple questions on ratios. Let me introduce proportion to this. All right, let me introduce some proportions to you. Let me introduce proportion here. Right, let me introduce proportion, then we will bring the ratios back. Of course, it's an extension. Let me introduce the word proportion. See, there are a couple of words, all right, that you might have to consider sometimes. You might have to consider all at once, because that language for kind of was used. Okay, pretty simple one. First, let us start with the basic understanding of proportion. What do you write in the proportion? You would have written something like this in the schools. Of course, primary school, class 7. A is to B is proportional to C is to D. All right, A is to B is proportional to C is to D. Like kind of analogies as well. After that, you put words. You would have learned in the same fashion. The analogies also you kind of write like this. Right, lot many stuff you did using the same symbols. A mathematically, man, what does it mean to us? Well, this part means A by B is also equal to mathematically. If I put this back in math, all right, now how does it look like? A by B is equal to C by D. All right, now this is what it technically means to us. If from here, what does it mean? The cross multiply. All right, you cross multiply them. Therefore, you say that A into D. All right, when you cross multiply, you also write it as A into D is also equal to B into C. How do you remember from your school's friends? You remember it like this: product of the extremes. Product of the extremes is also product is what? Into, isn't it? Into, right? Product of the extremes is equal to product of the means. Very important definition kind of you learn in the schools. All right, product of the extremes is equal to product of the means. Right, now you remember like that. Nothing but a simple math. It's nothing but a simple math. Okay, that's number one. So here, all right, now this D is also called as fourth proportion. D is also called as fourth proportion of A, B, and C. That's how we name it. Hey, what about C? Does this C has a name? No name, friends. The C has no name here. In this case, the C has no name. Only D has the name. All right, only D has the name. That is called as the fourth proportion of A, B, and C. Great. All right, let's consider another proposition here. Let's consider another proposition here. Hey, what if I have something like this? A is to B is proportional to B is to C. Can I have something like this? Of course, why not? Of course, you can have. So, for example, if you have 2 is to 6. All right, you wrote. All right, now let me write 2 is to, all right, now let me write it as let me write it as 1 is to 3, simple number. Let me write, all right, 1, let me write simple number. 1 is to 3 is proportional to 3 is to 9. Absolutely. What did you do? You repeated this number 3 again. You repeated that number. Can I do that? Yes. This is called as continued proportion. Continued, which means you stopped at B and you continued at B. So this is called as continued proportion. All right, this is called as continued proportion. Continued. Why did you didn't continue here? Earlier, what happened there? Earlier, already you stopped at B, but you started with C. Already you started with C. But here it's a continued proportion. You call it, you stopped at B, you kind of continue with B here, right? You continue with B. Fair enough. Now take a look at this. So what does it mean to us? So it also means something to us here. You can also write it as A by B. You're writing it as A by B is equal to B by C. Very important result. Therefore, B square is equal to AC. In other words, B is equal to under root of AC. Now, whenever B is equal to under root of AC, this B is also called as geometric mean, right? This B is also called as, now this B becomes the geometric mean of A and C, geometric mean of A and C. Therefore, whenever the things are in the continued proportion, remember A, B, C are in geometric progression. Geometric progression, they automatically become geometric progression when you write a continued proportion. Hey, what about B? B is the geometric mean, but in ratios. Instead of calling it as a geometric mean, we call B as the mean proportion of. B has a name, friends. B has a mean. B has a name. What is the name? Name B is nothing but the mean proportion of A and C. B is called as the mean proportion of A and C. Well, what about the C? The C is called as the third proportion of. C is called as the third proportion of A and B. C is called as third proportion of A and B. Just remember these names. All right, there was one odd question long time back. All right, in the exam, they may use a couple of definitions that you should use. What is the things that you should know from this slide? You should understand what do you mean by the fourth proportion. Well, whenever it is A, B, C, D, D is called as the fourth proportion. That is something that you should know. You should understand what do you mean by third proportion. Third proportion is a word used in the continued proportion. Well, whenever it is of this particular form, then comes into existence the third proportion. Then we have the mean proportion. B is also named as a mean proportion. All right, when you under the continued proportion, it's also called as a mean proportion. So that's another name that you should know. Which mean? It's technically geometric mean. It is technically geometric mean, but mean proportion. Under this, you also know that A, B, C are in GP. It's good to know these couple of elements in the proportion. There are a couple of things in the proportion. Nothing much. We are all comfortable writing the proportion because fundamentally it means this. Simple math. Fundamentally it means A by B is equal to C by D. Therefore, no big deal. We can easily handle this proposition. Not a great deal, right? Yeah, let's take some examples built on this, guys. Let's take some examples built on this. Let's take pretty simple examples built on this. Let's explore. So just you understood proportion, don't bother. Let's move further from here. Let's move. Okay, take a look at this question. One of the very popular kind of questions you get. One of the pretty popular kind of question. Right, again the word equal quantities. Right, this equal is a very important word. All right, with equal, already if you know certain concepts with respect to equal, things becomes, all right, now things becomes really quick. All right, things would become really quick. Okay, let's take a look at this. The proportion of milk and water in 3 samples. All right, there is a sample 1, there is a sample 2, and there is a sample 3. There are 3 samples. There is a milk and water. All right, milk and water in these 3 samples. Yeah, what is it? 2 is to 1. Milk and what? 2 is to 1. Second sample 5 is to 1. Second sample 5 is to 1. Third sample 1 is to 3. I already said it should be in the order because milk came first. First number stands for milk and the second one stands for water. I already talked about it. It's always in the order. There is no question and doubt about that. Okay, so now this is what you wrote there. Now what did he say? That hey, I took in equal quantities. Now look at the total, friends. Let me write the total here. If I write the total, 2 plus 1 becomes 3. I'm adding them, friends. 2 plus 1 becomes what? 3. Alright, if you add this here, 5 plus 1 becomes 6. If I add 3 plus 1, alright, here 3 plus 1 becomes 4. Therefore, it does not look like equal. It does not look like equal. Whenever you want to equalize certain things, understand that, okay, you got to go back to the LCM. You got to go back to the LCM. Now look at 3, 6, and 4. Alright, what is the LCM? Let's go back to the LCM. LCM of 3, 6, and 4. LCM of 3, 6, and 4, it is 12. Hey, what do you mean? Make everything 12. Make everything 12. There is a 3 here, make it 12. Make the total as 12. There is a 3 here, but make it 12. Okay. There is a 6 here, make it 12. 12. Decision made. What is the decision? Make it 12. We have decided to make it 12. But the point is, hey man, how do I make it 12? All right, how do I make it 12? All right, no, so 3 should become 12. Point is 3 should become 12, which means what do? Take it 4 times. Take this 4 times. Let me write it like this. All right, now consider this 4 times. Consider this entire proposition 4 times. Do it 4 times, it becomes 12, which means you had 3 liters here, 2 is to 1. Let's say that 3 liters. Take 4 times of that, it becomes 12 liters. All right, it becomes 12 liters. Hey, what I should be doing here? 6 should be made as 12. What I should be multiplying it by? Into 2. All right, 6 should be made 12. What I should be multiplying it by? Into 2. Hey, 4 should be made as 12. What I should be multiplying it by? 3. So which implies what? All right, now proportion. This is the proportion. All right, that's a proportion. There in the proportion, these 3 solutions, solution 1, solution. All right, now you got to take in this proportion 4 is to 2 is to 3 in that ratio. All right, you got to take it in that particular packages. Hey, what do you mean? Multiply this number 2 by 4, friends. Multiply this by 4. Hey, why 4? This 4 has to be multiplied to all these numbers because 4 into 3 has become 12. Therefore, this becomes 1 into 4. All right, this becomes 2 into 4. Every number should be multiplied this by 4, isn't it? Because you made 3 as 12. You made it 3 as 12. You took it as 4 times. Therefore, you better take the milk. Now, what is the quantity of milk? It has become 4 times. Hey, what about the quantity of water? That also has become 4 times under this consideration. Therefore, 4 into 2, 8. 1 into 4, 4. Great. Hey, what about the second one? Multiplied throughout by 2. Therefore, 5 into 2. All right, you are writing it as 5 into 2, 10. All right, now 5 into 2 is 10. 1 into 2, which has become 2. Perfect. All right, now 1 into 2 has become 2. What about the last one? Multiply throughout by 3. All right, now therefore 3 times, which is 9. 1 3 times, which becomes 3. Great. Add up all these numbers. Why? Because he's saying that find the final proportion of milk and water. Final proportion is what? Add these numbers. 10 plus 8 plus 3, which is 21. Is 2. What about the water, friends? Add them. 4 plus 2 plus 9, which is 17. Therefore, you are saying that the final proposition is 21 is to 17. All right, thus the final quantity that is formed is in the ratio 21 is to 17. Pretty simple one. So how did you approach this particular question? The word equal is important. Equal quantities. Take it as the LCM. Take the LCM and then equate it to that particular 12. You get the multiplying factor. You get the multiplying factor. When you take the LCM, you get the multiplying factor. Go ahead, multiply those numbers using those multiplying factors. You will get your final answer. You get your final answer. Try one more. Everybody try one more. The next level of this question. I hope all of you understood this underlying concept of LCM in this question. When the word equal comes here, when the word equal comes here, you understood this underlying concept here. Equal. Basically the equal. When the word equal came there. Right? Yeah, let's go further. Let's go further. Right, let's go the next one. Try this question, all of you. Try this, but it's just an extension to what we learned. We just have a small extension to what we learned. Okay, shall we? We'll do it together. Great. Okay. The proportion of milk and water in 2 samples is 2 is to 1 and 3 is to 2. They are mixed in the ratio 5 is to 2. Find the proportion of milk and water in the mixture thus formed. All right. Now, whatever the new mixture is formed, what is the proportion of milk and water? Look, earlier the word was equal. The mixed, all right, mixed in equal proportion. The earlier previous question, all right, these, all right, whatever was the composition, they were mixed in equal proportion. But this time they are mixed in the proportion of 5 is to 2. All right, they are mixed in the proportion of 5 is to 2. Via media, what you can do is, hey, make them equal first. Make them equal first, and then use this, after that. and then use this after that. Okay, you might not have understood what I said. Let's first make them equal. Forget this 5:2, friends. Forget this 5:2. Let's quickly make it equal to start with. All right, let's quickly make it equal to start with. So what do I have? I have the first sample. I have the second sample. Let's have the second sample. First, what we'll do is make it equal. Don't bother about this number 5:2. For now, don't bother about 5:2. Make it equal. What if my word was they are mixed in equal proportion? So let's make it equal there first. There is milk, water, milk, water in the first proportion. What is there in the first one? 2:1. Okay, 2 and 1. What about the second one? 3:2. Let's make it equal first. Total. Therefore, let me go to the total. What is the total in the first one? 3, 2 plus 1, which leads to 3. All right, therefore, that's 3. And what about the second one? 3, 2, which would become 5. 3, 2, which would result in 5. Great. All right, now that's what we have as of now. Okay, now, but it's not equal. 3 and 5 are not equal. So what do you do here? All right, now take the LCM, which is 15. So 15 will make it equal. 15 would make it equal. If 15 is making it equal, what do you do here? All right, into 5. This is what? Into 3. All right, into 3. Great. All right, now so far you get it here. So thereby 15 and 15 has become equal, which means 15 means what, friends? This is in the now ratio 1:1. All right, now what does it mean? Now it is in the ratio 1:1. Look at this 15 and 15. 15 and 15 means 1:1. Great. But then what did author say? Now open this game. Now open this particular game. He says that, man, I want 5:2 ratio, but you are writing 1:1 ratio. I am not interested in 1:1 ratio. Rather, I am interested in 5:2 ratio. Okay. If you are interested in 5:2 ratio, I will multiply this by 5 and I will multiply this by 2. Now, did you get the 5:2 ratio? Absolutely yes. If you are writing it as a 5:2 ratio, now look at this, guys. You already have a multiplication factor 5 and 3 here. So now bring this 5 also here. Bring this 5 also here. Therefore, what you are saying? 5 into another 5. Bring this 2 also here. Therefore, 3 into another 2. Therefore, what is the final multiplication factor? 5 into 5, 25. What is the final multiplication factor? 3 into 2. Okay, what did I do? First, I made it equal. What is the meaning of making it equal? 1:1. Then I open up the game. Now you want 1:1 or you want something else? Author wants something else. If you want something else, I will just quickly go there and I will find the new multiplication factor. What is the new multiplication factor? For the first number, it is 25 times. For the second number, it is 6 times. These are the multiplication factors. All right, let us write for the water, therefore. Let's write for the milk and water. 25 2 times 50. Let us write in front of this. Therefore, what you are writing? 25 into 2, 50. Hey, what is 25 into 1? 25. Great. That's a milk and water in the first solution. Let's come to the second one. Let's come to the second one. 6 and 5. Now 6 into 3, 18. The 6, friends. 6 into 3. That becomes what? 18. Then 6 into 2. That becomes what? 12. Now add them. Add them. You get the milk. Which is nothing but 68. That's a milk. Hey, what about the water? 25 plus 12. Which is nothing but 37. That's nothing but 37. Which is nothing but 37. This is the final ratio expected. This is the ratio expected. That's the reason, or that's the question he's asking. Tell me the milk and water. Pretty simple. Those who know how to get their multipliers, once you know how to get your multipliers, you kill this question in no time. Get your multipliers via LCM. First make it equal and then get to the new multiplier, what is required there. Now idea is what? Whenever they change, if they don't make it equal, you make it equal. And then open up this particular game. Becomes much faster. These approaches will make the question work a little faster and better. I'm not saying that this is the only hard and fast. This is the approach. No, I'm not talking about it. There are multiple approaches. We can approach it through fractions as well. But the point is, these numbers are pretty easier right now. Getting 25, getting 6. If you get them, you can close this question in no time. Becomes much easier. It reduces the burden on the brain. See, look, conserving energy is also very, very important through the course of the exam. You'll be writing the exams which span somewhere around 120 minutes. Most of the exams like CAT and in math, most of the exams will be spanning around 120 minutes. So when you got to sustain 120 minutes active, right? You got to sustain active. You got to conserve energy. You can't say that, okay, I take the approaches which are very tiring. I take the approach for RC which becomes tiring. I take the approach for LR which becomes tiring. I take some approach for questions in quant which becomes tiring. If you get tired, then your efficiency is not good for the entire 120 minutes. 120 minutes is a big time. It's a long time. And it's not a small time, it's a pretty long time. Now, if you don't conserve energy, if your strokes or your approaches are not good, what happens? You get tired doing a couple of RCs itself. RCs itself, because the approach is not good. Remember, therefore, build your approaches as well as you go along. Of course, I'm doing pretty simple questions in these initial stages. Pretty simple questions, but build your approaches as you go along. Great. Focus on the approaches as well. That's my point. Let's go further. You got that idea by now. You have got this idea by now. Let's understand how can I approach proportion in this particular question. Go ahead, friends. Go ahead. Take a minute. Take a minute. Think through. Take a minute. Quickly think through this question. Okay, right. All right. Let's see this. In the simplistic form, let's see this. How does this work? Monthly incomes of A and B are in the ratio 4:5. See, technically, if you write this, if you would like to go in little puristic approach, little puristic approach, not completely because that would that would not be really convenient. A little puristic approach might look something like this. Right now, A and B. Let's write them A and B. Income. Let's go to the income portion of this income. So how the incomes are 4:5. Technically you will write 4x and 5x, absolutely right. Then already you will come to the expenses. What is expenses ratio? 5:6 here, 5:6. Now don't write 5x and 6x. That's not the way, because in a one particular ratio, all right, that's one of the learnings of this question. If you have already used a x, now don't use the same multiplication factor x, all right, when you write a different piece of information. When you write a different piece of information, don't use the same value. So rather what you do, use it y. 5y and 6y. All right. So what about the savings? Savings is nothing but, what about the savings? Income minus expenditure. So income minus expenditure. How do you write it here? 4x minus 5y. How do you write it for B here? 5x minus 6y in this row. That's how you speak. 4x minus 5y, that becomes the x, that becomes the savings of the first person. So then you write 5x and 6y, which becomes the savings of the second person. Look, all it now leave here. One way of doing it is what? You can find the value of x, find the respective incomes. Incomes can be found out once you get the value of x here. All right, once you get the value of x here, this question is pretty simple, but I'm teaching the approach out here. Hey, I can solve these two equations. Say, what is that? Puristic approach looks like what? 4x minus 5y is equal to 25. Very good. All right, then you will say that 5x minus 6y, all it is equal to 50. Can I solve? Absolutely, you can solve, and you can get the values of x and y. But all right, now, so as we go along our journey, at some point, all right, the things are going to be a little tedious. What do you do? Take the ratios here and equate. Divide the first LHS. Therefore, you divide the RHS also. If you divide the LHS, you have the rights to divide the RHS. Simplify them quickly, because easier numbers are always good to deal with. Now cross multiply. It becomes 8x minus 10y is also equal to 5x minus 6y. Yeah, what do I get? You get the ratio of x and y here, right? Therefore 3x is also nothing but, all right, 3x is also nothing but 4y. This is what you get. So which means x and y are in the ratio 3:4. Guys, all you got to do is go to the income, multiply throughout by 3. Go to the expenses, multiply throughout by 4. Check what happens there. If you multiply throughout by 3, this 4 into 3 becomes 12, because x value, dummy value of x, you took it as 3. Well, that's what you took it here, because you got the ratio. You took the dummy value of x as 3 and the dummy value of y as 4. It's a ratio. Still, it is not the value of x. It's a dummy ratio. All right, which ratio? Ratio is 3:4. Actual value of x and y, you should actually solve, but you have no intentions to solve. You wrote it as 12. Fair enough. All right, now therefore, you multiplied the first row. 3 into 4 you did. You got it as 12. Great. All right, write the second number as well here. Write the second number as well. So therefore, you would say that next one, all right, 5 into 3, which becomes 15. Becomes 15. Okay, similarly 4 into 5, all right, which becomes, all right, so hang up, x and y are in the ratio 4:3, right? I made a mistake here. Come back, correction. X and y are in the ratio 4/3. I wrote it as 3/4, 4/3, right? Therefore multiply by 4 and 3. Right, yeah, this is 16, this is 20. You multiply throughout by 4. Next one, multiply throughout by 3, 15, and therefore you are writing it as 18. Now look at the savings here, friends. 16 minus 15, 1 rupee. 20 minus 18, 2 rupees. 2 rupees. But the point here is, what did author say? Am I saving 1 rupee and 2 rupee? Author is saying that no man, I'm not saying 1 rupee and 2 rupee, I'm saying 25 rupees and 50 rupees. Good. So 1 corresponds to 25. Therefore, naturally 2 corresponds to 50. Remember, which means the scaling factor, that is what you mean by proportion. The scaling factor for this entire chart is 25. Whatever the numbers you have in green now, whatever the numbers you have in green, that is 16, 20, 15, 8 and 1 and 2, whatever the numbers you have, that's what you mean by proportional increase, right? Scaling factor. Proportion is nothing but a scaling factor. So now this entire thing has to be multiplied by 25. This entire thing needs to be multiplied by 25. Therefore, author wanted his respective incomes, nothing but 16 into 25. That is one income. The second one is 20 into 25. That's another part of the income. All right, therefore, what you are trying to say? You are trying to say that A earns, all right, A and B friends, A earns 25 times of 16, all right, 25 times of 16, which is 400, 25 times of 20, all right, which is 500. Now, these are the respective incomes of A and B. Okay, I introduced the word scaling factor here. If you get the ratios, no problem. You get this particular ratio, go back, instead of finding two equations here, or this box, instead of you finding two equations, you can use the scaling factor to conclude this particular question. Just be aware of the scaling factor. Do I use in this question or in some other question? That's a different issue. I should be aware of the technique of scaling factor, because when we get on, all right, further into the time, speed, distance and time and work kind of chapters, we'll be using this scaling factor. From that perspective, I should know the scaling factor. Great. I introduced the word scaling factor. I guess everybody's clear on this. See, other way was what? Just solve these two equations. When you solve, all right, 4x is 4x minus 5y. 4x minus 5y is equal to 25, and 5x minus 6y is equal to 50. You can, of course, two equation, two variables, you can get the value of x and y. There is absolutely no problem. But I just introduced the word deliberately, the scaling factor. That's one of the faster ways to do as well. And it's also very important to understand that there is some scaling factor in proportions. There is a scaling factor, right? Let's keep that in mind. Let's go further. Let's go further. Beautiful cat question. Long time back, beautiful cat questions. Take a look at this question. Read it. Right, do it with me. All right, so how do you understand this? Okay, because he's saying that he scored an aggregate of 70%. It is good if you understand that every subject had all at 100 marks. Let me call the subjects as A, B, C, D, some subjects this person is writing. Assume that the maximum marks in this particular subject as 100, because the ratio is anyway abstract. I'm talking in terms of percentages here. So therefore, why not take it as 100, one of the convenient numbers. Therefore, calculating 70% and 60% is always convenient. Therefore, what is the total? Total is our friend's friend. Total is always our friend when it comes to ratio. Total is 500. Total marks are 500, 100, 200, 300, 105 subjects. Therefore, total marks is 500. Look at his aggregate. His aggregate is how much? 70%, nothing but the average. All right, he scored all right, now aggregate of 70% of the sum of the maximum marks. He's scoring 70% of this. Yeah, what is 70% of this? 350 marks. He scored 350 marks. The total marks of all the papers put together is 500. How much did he score? He scored 350 out of this. Right? Yeah, 350 out of this. Great. How did he score? In the first subject, he scored 3x marks. In the first subject, he scored 3x marks. In the second subject, he scored this is the subject marks, 3x marks, and the 4x marks. In the next subject, he scored 5x marks, and here he scored 6x marks. Here he scored 7x marks. 3 is to 4 is to, I'm writing it as a total because I got to equate it to this particular total. Great. I'll be adding all these numbers, isn't it? I'll be adding all these numbers. If I add all these particular numbers, it is becoming 35x. Well, it's becoming 35x. Therefore, you are saying that, okay, 35x is equal to 350. I added these numbers, 3, 4, and then 5, and 6, and 7. It has become what? 35x. Therefore, what is the value of x, friends? Value of x is nothing but 10. Right? Therefore, you are saying that the value of x, well, that's you added all those particular numbers. Hang on, I'm sorry. You added those numbers, it has become 25x. You added all these particular numbers, it has become 25x. 25x is equal to 350. All right, therefore, you get the value of x from here. All right, therefore, you get the value of x from here. All right, now 25, 25 12 times. All right, therefore, the value of x 16 times. All right, 20x is nothing but 16 times. Right? 16, just a second. 25 is right. 25x, which is equal to 350. All right, therefore you will say that therefore you would say that 14 times x is equal to 14. X is equal to 14. All right, therefore you say that okay, this is nothing but 14 times of this. So once x is 14, come to the marks of each subject. 3x, that is 14 into 3, 52. Here 4x, 14 into 4, 68. Sorry, 56. Right? Yeah. Now these are the marks he got out of 100 because the papers were 100 marks. This is the marks he got. Now his question is, in how many subjects he got more than 60%? Well, 1, 2 and 3. In 3 subjects he got more than 60%. In 3 subjects he got more than 60%. Great. All right, now keep this approach. This is a pure mathematical approach. All right, starting with 100 now, but listen to me carefully. CAT is always good at giving these kind of numbers. They might have twisted these numbers a little bit here and there, but look at the exam perspective. Examiners have a nice way of building the questions. They build the questions so that they know that hey, some of them are sitters, but if you don't understand them as sitters, that's your problem. That's how they deal with it. Hey, what do you mean by all it? What was the sitter here? Firstly, understand that these numbers are in AP. Firstly, understand that the given scores are in AP. 3, 4, 5, 6, 7 are in AP. If they are in AP, the middle term is nothing but the arithmetic mean, friends. The middle term is nothing but the arithmetic mean. Simple. And if the numbers are in AP, say even if what if the numbers were not in AP, which means already here instead of giving 3 is to 4 is to 5 is to 6 is to 7, intentionally they'll twist it. They'll say that okay, in the subjects he scored 3 is to 4 is to 5 is to 7 is to 6. No problem. All right, now these are the subjects A, B, C, D, E. Can I rewrite them back in the order? Why not? You write them back in the order, arrange them. When you arrange them, you understand that man, they are in AP here. Assume already if they are in AP, this is an AP series. The ratio of the marks are in AP. If they are in AP, the middle term is nothing but the arithmetic mean. If it is the arithmetic mean, that is equal to 70%, that's aggregate average. That's average because average is the middle number only, that is 70%. Therefore, no, look at this. 5 corresponds to 70%. 5x corresponds to 70%. 5x corresponds to 70%. Then what does x corresponds to? 14%. X means 14%. Therefore, you have the scores as 3x, 4x, 5x, etc. 6x and 7x. Therefore, anyway, this is 70% qualified. You got to find out which got more than 60%. Therefore, you know x is equal to 14 right from here. Therefore, 3 into 14 and then 4 into 14. That is the simple calculation that you would have done. You don't do this in the exam. You don't do this. Rather, you do this. Why? Because you understand the given numbers are already in AP. Once you understand that particular proposition, it becomes a mental calculation. Beautiful CAT question. You just have to understand that how the approaches are. You got to be careful to the stimulus. Well, its stimulus is very, very clearly set, saying that I am giving the numbers in AP. So why don't you understand that the middle number 5 corresponds to 70% and finish this problem in no time? Finish this problem in no time. Great. All right, now the answer to this question was 3 subjects. All right, in 3 subjects he scored more than 60%. 60% answer is 3 to this question. There we go. All right, you are understanding the stimulus here clearly. So all right, now despite knowing the ratios, proportions, etc., be open to the stimulus. A little basics of geometric mean, little bit of basics of arithmetic mean. If you're just closer to the numbers, if you observe the numbers closely, you can close the issues in lesser time. Well, that's what most of the management exams look at, not just the puristic approach every time. They also want to understand that, hey, are you observant about the numbers being used there? Because they're intentional. In 3 is to 4 is to 5 is to 6, it's pretty intentional in this case. But you don't understand the author intention, then it takes simply longer time out there. Fair enough. Let's go further. I hope you are getting the intent that I'm talking about. You're getting the intent. Let me introduce another concept. We are into the last 30 minutes of this game. Let me introduce another concept, that's a variation. Direct, inverse, and compound variation. Right? Let's understand this. What is direct variation? Now think about this. Let's generate the numbers. Sometimes what happens is when we write these numbers, people tend to think that they are direct. Now let's say that A and B. There are 2 things A and B. Well, 2 things A and B. Let me write some numbers for you, friends. 23, 247. Then you have another number, 83, 936. Okay, let me write 87 here. Okay, then I wrote 121, and then the corresponding value is 1342. Right, something like this we wrote. out. Something like this we will. Now, if I ask this already in the class, I generally ask this, okay, A and B, all right, now are they directly proportional? Are they varying directly? Are they varying inversely? Something like this. What do you mean by varying directly? A varies directly with B. A is directly proportional to B, or A varies directly with B. Both are same, right? Now, so can I use the word A directly varies with B, or A, all right, now A is directly proportional to B? Fair enough. All right, both languages are fine. There is no issue with that. A is directly proportional to B here. So, all right, now A is inversely proportional. Should I write this? All right, if I ask this, A, should I write this for the given relation, or should I write this with this? Most of the people often say that they look at these numbers. They'll say, as you are increasing the value of A, B is also increasing. As the value of A is increasing, 23 went on to become 87, this also increased. 87 went on to become 121, this also increased. All right, now that's one side of the proposition. Keep it in mind. All right, let's keep it in mind. Therefore, most popular answer that I get is 1. A is directly proportional to B. Fair enough. All right, let's keep that. All right, let's keep that A is directly proportional. Let me give you a proposition here. Think about it, friends. Think about it, A and B. Let us say that A is nothing but the pencils. You are buying certain pencils, and then there's an amount being paid. All right, this is the amount being paid. Great. So let's say that, all right, this is the proposition. 20 pencils cost. All right, cost of 20 pencils is 50 rupees. Cost of 20 pencils is 50 rupees. See, I wrote this, let's say cost of 20 pencils is 50 rupees. You gave, already you went to a shop, you found that cost of 20 pencils is 50 rupees. Good. So from here you are saying that, hey, what is the cost of 10 pencils? Therefore, how much you are willing to pay for 10? You don't need 20. You said that I need pack of 10. So how much you are willing to pay? Technically 25. 25. All right, cost of 10 should be okay. Hey, what about, all right, now I wanted 40, not 10. All right, I wanted 40 of them, 2 packs of it. You have to pay 100. All right, you got to pay 100. Simple calculation here. Now look at this. Now here clearly A is directly proportional to B. You produce these numbers. All right, we produced it together. A is directly proportional to B. What does it mean? As the value of A increases, the value of B is increasing. But the word here is variation, all right, or proportion, means they're increasing proportionally. What does it mean, guys? Now take a look. All right, now A, how do I get rid of this symbol? All right, A is directly proportional to B. If I want to bring equal, what do I get? K times of B. I introduce a constant. A is equal to K times of B, K into B. All right, no, K into B. All right, therefore you say that, hey, therefore you say that A by B is equal to constant. Nothing but ratio is constant. Ratio is constant. That's a value here. That's a point here. All right, A by B is equal to K. Directly proportional means what? A by B is equal to constant. In other words, ratio is constant. That's a very important word. Ratio is constant. Think about it. Go here. Think about it. 10 by 25. Write it here. 10 by 25. Hey, what is the ratio, guys? This is 2 by 5. All right, this is 2 by 5. All right, 5 2 times on this. This is 2 by 5. Hey, what about 20 by 50? That's also 2 by 5. Hey, what about 40 by 100? That's also 2 by 5. Now listen, that ratio has to be constant. But in my given example, this ratio is not constant. 23 divided by 247 is not equal to 87 divided by 936, which in turn is not equal to 121 divided by 1342. Therefore, it is neither directly proportional nor inversely proportional. It's a proportion. Proportion means something like a scaling factor. You had 10 and 25. If you scale it by 2 times, you should get 20 and 50. If you scale that by again some 2 times, you should get the next one. Proportional increase, not just increase. Of course, there is an increase. If you look at this question, hey, isn't there an increase? Of course, there is an increase on both the sides. As the A value is increasing, the value of B is also increasing. I'm not denying that fact. But is there a proportional increase? No. If there is a proportional increase, the ratio becomes constant. If there is a proportional increase, the ratio becomes constant. Remember that fact. All right, great. All right, let's go here. Let's go from here. That's a point here. That's a point about the direct variation. That's a meaning of the direct variation. Be mindful about the word proportional increase. Be mindful about that. Nothing but the scaling factor. Be mindful of using the scaling factor across the numbers. That's important there. All right. Let's go to the inverse, friends. Let's quickly go on to the inverse. Let's understand what is inverse here. We understood direct, which means ratio is constant. All right, that's the meaning of ratio is constant. Let's go to inverse for a while. Let's quickly check that before we get on further. All right, inverse there. So A and B, let's assume that what is A and B? This time let me take it as number of people or students who are working on a particular project. All right, therefore number of days it is taking. All right, it's fixed. All right, company has its own working style and number of hours per day. All right, all right. Now they got a project. They estimated that particular project. They said that, okay, if I put 20 people on that project, or if I put 20 people on that project, 20 resources on that project, they will complete it in 30 days. they'll complete in 30 days. That's what the fair estimation they arrived at. They said that, okay, if I put 20 people there, 30 working days are good enough to complete this particular project, a month. All right, 30 working days are good enough to complete this project. But they found out only 10 people working on that project. All right, they said that, okay, I will get 20 people, I will put 20 people on that project, then I'll be able to finish in 30 days, right? Finish in 30 days. Now I put 10 people on this project, we all know obvious answer, 60 days. 60 days, not 10, 20, 15 days, friends. If I put 10 people on that project, because I did not get 20, therefore I said that, okay, 10 is what I got now. If I get 10 of them, then they will be taking 60 days to complete this project. Great. Instead, assume that, okay, there were a lot of people on the bench. There were a lot of people already know, though, at that point in time, who were free in that particular company. Great. I will put them on this particular project. Therefore, instead of 20, I put 40 people on that particular project. Then the project gets done in about 15 days time. Then that particular assignment or project gets done in 15 days time. That's a point here. That's a point here. Now what is that you are trying to say? You are trying to say that as I am increasing the people 10 to 20 to 40, the number of days are getting reduced. Number of days are getting reduced. Already, if there are 10 people, I wanted 60 days, 20 people, 30 days, 40, 15. Look, again, alright, there is a proportion there. Inversely proportion, that's right. Alright, as you said, it's inversely proportion. A is inversely proportional to B. We write it like this. We write it like this. Hey, I want to get rid of that proportion sign. What do I write? A is equal to K times K into 1 by B. K times of 1 by B. So look at this, friends. What is that? Therefore, A into B is equal to constant. In the sense, whenever they are inversely proportion, product is constant. That's my point. Product is constant. Product is constant. Take a look at that. Let's go back to them. Product is constant. That's how you understand them. All right, people did not have to tell me that they're inversely proportional sometimes. If I get the product constant, then I know that, okay, they're inversely proportional. Think about this, 10 into 60. Well, think about this product. What is 10 into 60? 600. Hey, what is 20 into 30? Absolutely, that is 600. Well, at 40 into 50, that's 600. Whenever I get product is constant, that's a clear indicator that the numbers are inversely proportional. The relationship is inversely proportional. Therefore, remember, ratio is constant, directly proportional. Product is constant, inversely proportional. Remember these words, not just these fancy symbols. It's not about these fancy symbols. A is directly proportional means, oh, I used to write like this in math. Beautiful. It looks good to me. This looks good to me. It's not about looking good there. All right, it's about, idea is about, hey, is product constant means inversely proportional. Ratio constant means directly proportional. Hey, what is a compound? Compound means there can be more than two things. All right, no, not just A and B. I might have A, B, C, a relationship undercurrent running between A, B, and C. All right, that's called as the compound. I'll take an example. Through example, let's understand what is this compound variation or what is this compound proportion that we talk about. Generally, compound proportion does not exist. Compound variation is the right word to use there. Right? Let's take examples here. Simple examples. Let's illustrate, friends. Let's take few examples. It's one of the CAT questions. CAT questions. Let's do this. Just read it. Take a minute. Take about 30 seconds to 40 seconds. Read this question. We're into the last 20 minutes, all right? About the last 20 minutes, we'll finish. I guess you might have read. Let's do it together. Push yourself, push yourself. I know that, okay, now sitting for about 2 hours continuously is always a challenge. That's there. But then you need to have that kind of strong will. It is required. It's required. You got to push. That's a way of building stamina as well. And it's always a good news that when we come to the fag end of that particular activity. All right, now that's why people already, when they're writing CAT, they tend to do well in quant the last couple of minutes. Reason being, they know that, oh, it's all over. 100 minutes are done. I'm just left with the last 20 minutes. Generally, already there's a rush of energy and people generally do well in the last 20 minutes. I hear this. A lot of people, when they come out of the exam hall, they keep saying that, oh, last 20 minutes I really rocked. All right, unless you become pretty nervous. All right, most of them, I'm not saying all of them, most of them generally say that, oh, the last 20 minutes I was at my best, I kind of did it. But despite being tired, how can you are at your best? Because always, all right, change of activity, when you know that you just are left with some time, you are kind of going to do really well. That's a human nature. That's a technically human nature. Great, let's go here. We are into the last 20 minutes of today's lecture. Great, let's go here. The cost of the diamond varies directly as the square of its weight. What is that author is trying to say? All right, now relationship, if I want to write cost, let me write it as the value. All right, cost, let me write it as V. All right, the value of this value directly varies with the square of its weight square of its weight. A diamond of worth 7,500 fell down and broke it into two pieces whose weights are in the ratio 2:3. Now listen, friends, let me take a 5 gram diamond, 5 gram. 5 gram diamond, let me just take a 5 gram diamond, it broke it into two pieces. Therefore what it has become, all it has become, all at one piece has become 2 grams, the other piece has become 3 grams. You may say that, hey, why I should take 5 grams, can't I take 50 grams? Proportional does not matter, your answer remains same. If required, we will see it towards the end, we'll see it towards the end. That's the beauty of writing the proportion, because it's a scaling factor. Therefore all it does not really change. Can I make 5 grams as a 50 grams? Does not matter. Or take a number which is the which is the sum, always sum is the number, right? Or addition, total, what is the total? Therefore total is 5 grams. Therefore you are saying that, okay, so what is the value it should fetch, friends? What is the value it should fetch? Therefore here, all right, value it should fetch, value it should fetch, all right, the first one, the value, I'm writing the value here, the value it should fetch should be 25, 5 square, 25 times of k. Why? Because you will say that v is equal to k times of w square, because I don't want that proportion based, this is based on the first statement, right? Based on the first statement I wrote that condition, v is directly proportional to weight square, nothing but v is equal to k times of w square. That's what I need to be writing. So therefore what do I write? If I put the value of w is equal to 5 here, if the value of w is equal to 5, I get this 25k. Great. Now this is what it is supposed to be fetching, which means if the diamond is not broken, I should get 25k. Okay, but then what did I get? All right, now 2 square, that is 4k I'm getting. 3 square, square friends, it's a square function. 3 square, 9k I'm getting. Because now it is broken into these two pieces, I'm getting only 13k. I was supposed to be getting 25k, but I'm getting only 13k. What is the loss I'm incurring therefore? 12k, that's a loss. Loss I am making is 12k, because 25k is what I was supposed to be getting. What did I get now? I got only 13k. Hey, what is the loss I made therefore? 12k is the loss I made. 12k is the loss I made. Now listen to me. What is the worth of the diamond? 75 7,500 corresponds to what? 7,500 corresponds to what? 25k. 25k implies that 7,500. Can I find the value of k from here? You can find. You need not find. Choice is yours. So what is that? I'll let know. You know that 25k corresponds to 7,500. Therefore 12k corresponds to what? Why 12k? Because loss is what we are talking. Loss is what you are talking. What is the loss, friends? Loss is nothing but 12k. You can directly get that relationship. Therefore loss is equal to 25k corresponds to 7500. Therefore 12k corresponds to what? You can bypass. K is not important. K is just a constant guiding you. K is just a constant which is guiding the problem. All right, don't pay special attention to that k, not required. All right, no special attention that it requires. Okay, 25 3 times. All right, therefore 300, 12 3 times, therefore you will say that, okay, 36, all right, 36, all right, 3600 is the required answer. This person is making a loss of 3600, all right, in this process, because the diamond went on to break down. Simple relationship. The idea is not about k, because a lot of people will be more worried about k. All right, in critical problems k is required, not in every problem. In every problem k is not very important thing there. Okay, I hope all of you got this very simple question. All of you got this. Okay, let me bring the dimension there. You may be wondering, no, why didn't we take it as 2x and 3x and write it as 5x? Listen to that. Okay, if you write x here, all right, if you write x here, you would have said that, okay, let the weight be 5x. You would have written 5x here, friends. All right, here you would have written 2x, and here you would have written 3x. Great. Now then you would have written 25k x square, 4k x square, because there is x now, that also gets squared. This will become x square. This has become 35k x square. This will become 25k x square. When you come here, you are writing it as 25k x square. You just have to write that x square. Here also you are writing x square. Here also you are writing x square. What happened to that x square? Ultimately got cancelled. Now that is what you realized in the beginning. All right, that is seeing the end from the beginning. All right, that's how you see sometimes, because based on your experience with the math, already you will say that you can see the end from the beginning, in the sense, hey, I can write this x, but that fellow will simply come and get cancelled towards the end. Why should I therefore write that x throughout? No, you don't. Already you don't have such control. You don't know much about that. Then you better write it. No problem. If you don't have that control, you write it. No, I have that control. Don't write it. Choice is yours. Choice is yours. All right, there is no hard and fast rule to that. All right, choice is yours. Fair enough. Let's go further. But ultimately, I want you to, all right, now not write that particular x. Ultimately, you have to reach that particular stage where you don't pay attention to unnecessary details. Pay attention to necessary details, and don't pay attention to unnecessary details in the problem. All right, great. All right, let's go here. Let's go here. Let's understand this simple one. A simple question. Read it. Take 30 seconds. Okay, let's say this. All right, partially you can apply the inverse relationship here. Now listen. All right, there is a garrison. How many people are there? 750 people are there in that particular group. So how many provisions, which means there is a food provision. How many days it lasts? 20 weeks it lasts. Right now they have some food, may not be complete food. All right, now a type of food, maybe all right now say the dry fruits. How long the dry fruit lasts? All right, now maybe about all right now 20 weeks. Right now therefore about 4 to 5 months. All right, now that's an amount of dry fruits that they have stored. Okay, the word dry fruit is not there. Some provision. There is some provision. If there are 750 people, they can consume it for 20 weeks. Great. At the end of 4 weeks, which means 4 weeks are gone. Hey, what is the amount of provision left now? What are the amount of provisions left? Amount of provisions left is all right now for 750 men can consume it still for 4 weeks. 7 all of 16 weeks, 4 weeks are gone because they can earlier consume it for 40 weeks, 20 weeks. Now their 4 weeks are gone. 4 weeks are gone means how many weeks are left? 16 more weeks are left. 16 more weeks. 16 more weeks. If the same 750 men continue to be there in that particular, continue to consume those provisions, the remaining provisions can be consumed for the 16 more weeks. But what happened? There is a reinforcement. They added 450 more men. They added 450 more men. 750 plus 450, 1200. Now you are saying that there are 1200 men. Therefore, already it will leave for how many more weeks? That is the question. How long will the provision last at this from this particular point in time? How long does it last? Now think about this. Are they directly proportional, inversely proportional? Simple, they are inversely proportional. More the men, it will last for less weeks. More the men, because the provisions are constant. Whatever the leftover provisions, that is anyway constant. If you are adding men to this, all right, naturally the provisions will get consumed little faster. Therefore they're inversely proportional. When they're inversely proportional, what did I say? Product is constant. Simple, all right, product is constant. Therefore what is that you are trying to say? 750 into 16 is equal to 1200 men into number of weeks, x weeks. Let me write it as x. All right, x weeks. Yeah, because what we understood, they're inversely proportional. Is there a word inverse here? No, it is not there. It need not be there. We know the common sense. We know if more people are there, then the supply will last for less time. If there are more people, the supply will last proportionally less time. Proportionally less time, assuming that their consuming ability is constant. Nothing is mentioned. Therefore, they consume whatever they have to get as their share, as a ration. They'll get exactly that much quantity every single day. Right now, therefore, already you say that product is constant. Whenever they're inversely proportional, what did we say? Constant. Product is constant. Precisely, that is what we are trying to do out here. All right, that's what we are trying to do out here. Right, so therefore we'll simplify. We'll get the value of x from here. All right, we'll get the value of x from here. This is 155 times, 155 times, 158 times. Let 158 times, 155 times, and 158 times. Right, yeah, then 8 one time, then you will say that 8 two times. Therefore what is the value of x here? 10. Already instead of lasting for 15 weeks, you are saying that man, it is now going to last for 10 weeks. Simple one. So now what did you do? All right, now in between the problem you applied the inverse proportion. You don't have to apply the inverse proportion or direct proportion on the entire problem sometimes. That's fine. Out of 20 weeks, he started off by saying 20 weeks, out of which 4 weeks are gone. Great. If 4 weeks are gone, you are left with only 16 more weeks. Therefore carry on the problem with that leftover 16 more weeks and understand that how many more weeks it will last. It will last for another 10 more weeks. Simple problem. Let's go further. Let's go further. We have seen one example on direct, one example on inverse. Let's see one example on compound variation. One example on compound variation. Let's take a look at this question. Take 30 seconds, 45 seconds, 30 to 45 seconds. Read this question. Read this question. Right? Okay. No, it looks more like a science problem. For some of you, it looks like, oh man, what's happening here? Pressure, volume. You don't bother. You just carry on with your understanding of ratio proportion. That's important. A little often, some people might leave this particular question for a simple reason that, okay, this fellow is talking about the pressure, the gas, Pascal. So what is this? All right, Kevin. All right, some of you may think that, man, I never heard about these words. All right, maybe I heard long time back in the high school or something. After that, I really don't remember what are these particular words. You don't bother. You just focus on, because anyway, is there a conversion here? There is no conversion. Kevin and Kevin are matching. Pascals and pascals are matching. If you say there are meter cube, only volume in meter cube matching. Therefore, what all abstract because everything is in the same term. So therefore, you don't have to bother. When you have to bother, if there is a conversion factor. If you say that man, temperature from Kevin, you convert it to degrees, then you will say that, oh, leave this. Now it's becoming a pure science kind of question. I don't remember these kind of conversion factors, converting Kevin to degree, Kevin to degrees to Fahrenheit. I don't understand. That's fair enough. That's fair enough. Right now, but on the face of it, you don't leave these kind of questions. Okay, let's firstly understand what is compound relationship here. What is this compound? Now listen to me, friends. So three things: pressure varies directly with the temperature. Fine. This is how you write: pressure varies directly with the temperature. Good. When the volume is constant. Okay. Now you will say that V is constant. V is constant. Keep it. All right. Now you don't bother to do too many things in these things. Keep it. Okay. Next one. All right. Pressure varies inversely with the volume when the temperature is constant. Right. The second line. Pressure varies. All right. There is always one thing which is common. You can't bring in too many other things. Sometimes the temperature can be common between two information. Pressure can be common or volume can be common. In this, what is common? The pressure. Pressure is the keyword. Therefore, again, I am relating the pressure. Pressure is inversely proportional to volume. Inversely proportional to volume when the temperature is constant. All right, now I need to combine both of them. All right, what is there on my left hand side? Pressure. Keep it. All right, I need to combine both of them on this side. Okay, therefore pressure is proportional to, where is T, friends? Numerator. Where is V, friends? Denominator. Pressure, all it now like this. Okay, if I don't know the complete formula for pressure, don't bother. This is all which has been given. Pressure is directly proportional to T in the numerator, V in the denominator. Put it together. So therefore, okay, I don't want this proportionality symbol. No problem. All right, get out of that. So what is proportion? If you don't want, P is equal to K times of T divided by V. Simple. All right, P is equal to K times of T divided by V. All right, that's all the simple thing that you are writing. P is equal to K times of T by V. Fair enough. All right, solve this question from here. Let's solve it from here. So now let's put the perspective. First one, 28 pascals. Apply it here, friends. All right, this is the key here. You got the key. Apply it in the key. All right, first case 1, 28 pascals is also equal to K times of temperature, 300 where numerator, volume 30 where denominator. Good. So that's one information. What is the second information? Find pressure. Don't know. All right, now that is X. That's what you are trying to find out. Pressure in the second case is X. You are calling this as X and you want to find this. When the temperature is 360, great. Temperature is 360, numerator. Volume 42 where denominator. K times. Now what to do? You can find the K from the first one and substitute in the second one, or you have two equations. Simply divide and equate. Simply divide and equate. LHS if you are dividing, RHS also you better divide. Simply divide and equate both of them. Great. If you are dividing and equating, KK cancel. KK cancel. Simplify them. All right. Therefore, this becomes 10 times. All right. Now this is becoming, all right, 660 times and 7 times. 7 times, right? Now therefore from here, all right, now so you will say that X is also equal to, this is 10 one time and this is 10 6 times. Therefore you will say that, hey man, this is nothing but 28 into, all right, 28 into 6 into 7. That becomes the value of X. Well, that's what you're writing there. Therefore 24. All right, therefore X is nothing but 24. You got the answer. So you got the pressure as 24. Okay, my point here is you also don't have to find every time what is the value of K here. All right, you understood in some of the questions. K is irrelevant. That get auto cancelled more often than not. Sometimes it is required. More often it is not technically required. Right now that's also you are kind of realizing. You understood the compound. No problem. All right, compound is not a big, all right, no, it's a big, all right, no, it's not a big concept or something. It is fine. Instead of having only A and B, you will have ABC kind of. What do you have here? You have the pressure, you have the temperature, you have the volume. Fine. Wait for the common stimulus. Write it on one side, write the other things on the other side, and club them together. There you got the relationship and get going from there. All right, get going from there. Good. Let's go further. Okay, before this, all right, let me go to direct relation and inverse relation. Just listen to me one point. We'll do two problems and we are done. All right, we'll do two problems and we are done. Now listen to me. What is direct variation, friends? Listen to me quickly. I will write in this corner. Very important. Yeah, what is direct variation? Direct variation means you wrote it, all right. What is direct variation? You said direct variation is nothing but A is equal to K times of B. That's a direct variation. K times of B. Okay. What is inverse variation? What is inverse variation? All right, what is inverse variation? You wrote A is equal to K divided by B. That is K into 1 by B. Nothing but K divided by B. Now remember, what is direct relation? Sometimes the management entrance exam, they also ask questions on direct relation. What is direct relation? A is equal to K times of B plus C. K times of B and another constant. All right, now, so you can see, you can let me write it as K1. K times of B plus K1. There is already a K here, put it, and another constant. It's not a variable, another constant K1. It's going to be another constant K1. What about the inverse relation? What about the inverse relation? Inverse relation is nothing but A is equal to K by B, all right, K by B plus, all right, plus K1. All right, plus K1. What is that? There is little more constant factor to it. All right, this constant factor is coming in the play. All right, that's a difference between direct variation and direct relation, inverse variation and inverse relation. Okay, let's take some example here. Look at this. This is a question on inverse relation. This is a question on inverse relation. Take a look at that question. Now you read. Now let's read that question. We'll understand in a while. Let's understand this. Read that question quickly. We'll do it together. We'll do it together on the last 5-6 minutes. 6 to 10 minutes based on the way you understand it. 2 questions and we are done. We are sorted. Right? Okay, let's take a look at this. Total expenses of running a hostel are partly fixed and partly varying. Something like that. Partly fixed is what? Already you are running a hostel. Let's assume that okay, you took that particular place on rent, right? Now, therefore, whether there are inmates or not, you got to end up paying that rent. That can be something like fixed. Hey, what is partly varying? Maybe the food expenses of the people, or maybe the maybe the bedding expenses of the people. Right now, you have to change the keep changing the bed sheets. You have to keep changing the blankets. All of that. Right now, that can be partly varying because if there is nobody, there is no cost on bedding, etc., etc. You don't have to keep changing, washing the things, etc. Right now, therefore that is partly varying linearly with what the number of borders, as the number of borders are changing. Now look, all right, now so this is what I meant by hey, partly fixed. All right, this is what you mean by partly fixed and partly varying. Right now, linearly, partly fixed and partly varying. Therefore, already you say that hey, there is something varying, something fixed, or it can be like this: it is varying and it is fixed. That's what you mean. That's when you quickly understand that man, this is nothing but inverse relation. Why? Because there is some constant part and there is some varying part. All right, now this is a constant part. It's a fixed part. This is fixed. All right, that's a constant part. That's constant fixed. Now that's a varying part. All right, now A varies with this. It's a varying part. Or this, it's a varying part. Now I need to understand that are they increasing or decreasing. Now take a look at this. The average expense of the boarder is 7,000 when there are 25 boarders. Okay, when there are 25 boarders, they're paying this much. Good. So when there are 50 boarders, they're paying less. If they are paying less, then it's an inverse relation. Simple. It's inverse relation. All right, if it's a direct relation, as the people increase, the amount should increase. But what is happening here? As the people are increasing from 25, when it is becoming 50, the amount is changing from 7,000 so 6,000. Therefore, it is decreasing. Right? If it is decreasing, it's an inverse relation. It's an inverse relation. Let us write this therefore. All right, now that's how you understand the question. The moment you read this question, you will understand that man, it's an inverse relation here. Or it is an inverse relation. Therefore, if you understand inverse relation, it can be quickly sorted. All right, this can be quickly sorted. Let's sort it. Let's sort it. What is given to me therefore? You are saying that the hostel expenses, let me write it as E. The expenses per person. What is this expenses per person? They have to pay about 7,000 per person, right? Expenses per person. Great. Hey, what is the expenses per person, friend? Expenses per person is nothing but K times of. Or let me write K1 first. Can I write K1 first? Yes, I just already the order. All right, no. So there is an order to that. Okay, let me write it as fixed expenses. F. I will write as fixed expenses. All right, there is something there. All right, now let me write K1 itself does not matter. So what you are trying to say? All right, now this expenses is nothing but, all right, these expenses are nothing but, all right, there is a cost F. All right, there is a cost which has to be shared among 25 boarders. Among 25 boarders, and each of them are going to pay some variable cost called as V. I just wrote it in this particular order. K by B, I wrote it as F. I wrote it as some value called F. That F has to be shared between 25 people. Or F has to be shared between 25 people. Hey, what is that F? It's a fixed expenses which will be shared between 25 people. I will tell you how. I will tell you how. Assume that right now he is paying a rent of 10,000. He is paying a rent of 10,000. If there are 10 people, find 10,000 divided by 10. Each one of them end up paying 1,000. Okay. Now assume instead there are only 5 people. If there are only 5 people, this 10,000 you divide by 5, each one of them will end up paying 2,000. What is the variable cost? Because you are living there, your food expenses, etc., etc., you have to take care. All that will be paid. Now that is how it is happening. Therefore, I wrote this as f divided by 25 plus v. All that becomes my fundamentally the first equation. What is the second one? Okay, let me write let me write it as n first. General form. F divided by n. That is what f divided by n into v. This is my general form. This is my general form, right? Okay. So now therefore let me write this. Let me write these two equations quickly and solve. Let me write this equation and solve. See, only problem with understanding this question was, had you understood it's an inverse relationship, you would have written those two equations and finished in within a minute's time. That is it. If you understand it that way. Otherwise, you'll keep doing some conversions, etc., which will take some time. Now that we understood it's an inverse relation, this is the shape. We will close it quickly. We'll close it quickly. So what is that we are trying to say? F divided by 25 plus of v is also equal to 7,000, case 1. First equation. Second one, I'm writing the e other side. That's it. Second one, f divided by 50. Now there are 50 borders. F divided by 50 plus v is equal to 6,000. Two equations, solve. Subtract the second equation from the first. Just subtract. Let's subtract the second equation from the first. Therefore, f by 50. Because others are getting cancelled, f by 25 minus f by 50 becomes what, friends? Becomes another f by 50. Solving f by 50, v and v got cancelled. Therefore, f by 50 is equal to 1000. Therefore, you got the value of f from here. Great. What is the value of f? Therefore, value of f is nothing but 50,000. Value of f is nothing but 50,000. Good. All it now that's a value of f by 50. F by 50 is 50,000. Put this in one of the equations. Let's say that f is equal f. I will put it in this particular equation. 50,000 divided by 50 becomes 1,000. 1,000 plus v is equal to 6,000. 6,000. Therefore, you got the value of v also. Therefore, value of v is equal to 5,000. Value of v is equal to 5,000. You got the values of f and v here. Great. All right. Then he's saying that find the average expenses per border. Great. I will go back to the average expenses per border. So from here, expenses per border, e is equal to expenses per border. What is the value of f, friends? 50,000. Divided by what? Divided by 100, because now there are 100 borders here. Divided by 100 plus what is the variable expense? 5,000 per border. 5,000. Therefore, that is going to be what? 5,000 divided 5,000 and 500. Therefore, you say that, man, this time the expenses for 100 borders has become 5,500. That's answer. 5,500 is the answer. All right, 5,500 becomes your answer. That's pretty much about this. All right, inverse relationship. Let's do one last question and we'll wind up with that particular question. All right, 5,500 becomes the answer there. Okay, all of you understood this. It's just all right. If you understand it's about inverse relationship, you would have written this in no time and you have concluded this question. That's it. You would have written this expression in no time. You solve it and you'll get your answers in no time. Just go back all right. If you didn't understand in the first go very clearly, I wrote that notes. I said that what is the difference between direct relation, inverse relation, or how they are different from direct variation and inverse variation. If you are just mindful about it, either the question can come on direct relation, direct variation, inverse variation, or sometimes it's on the direct relation and inverse relation as well. Let's stop with one of the nice cat questions. Let's take up this particular question. Beautiful cat question. We'll stop with this. Another few minutes. Let's do this. Today we are taking little longer time because I've been trying to explain some things repeatedly for your good. Let's solve this and close. Well, guys, do it with me. Let's do this together. Let's do this. Do it with me here. Now, what's given? All right, let's connect these two sentences here. Let's connect these two statements. One, speed of the train. All right, there is some ideal speed. We'll come back to this. Speed of the train decreases with every single wagon attached. But decreases how? In what proportion? Here underlined one. Decrease in speed is directly proportional to the square root of the number of wagons attached. Square root. The word is square root of number of wagon attached. So what is happening? Reduction in speed. Let me write it as SR. Only those two underlined statements I'm connecting now. I'm connecting these two. Reduction in speed. Let me write it as SR. Reduction in speed is directly proportional to square root of number of wagons attached. Let W be the number of wagons attached. You can write N also. Let N be the number of wagons attached. Absolutely no problem. Well, I'll write it as W is the number of wagons attached. Therefore, you are saying that reduction in speed is this. Okay. Well, now open up. You would have already read this question further. All right. Now, therefore, read this particular question. A goods train can travel with no wagons attached. 60 is the no wagons attached. That's an ideal speed. Let me write it as speed ideal. Ideal, which means no load attached. Don't give any load. Don't attach any load. Laboratory condition. Ideal condition. Ideal speed is 60 kilometers per hour. But the point is the speed start. All its speed gets cutting. All it's got cut. Therefore, it becomes an actual speed. Therefore, look at this, guys. All know what is this proposition? Author first wanted you to understand that. Look, actual speed, SA, that speed actual is equal to speed ideal minus speed reduced. Ideal speed, and you keep reducing it, therefore you get onto the actual speed. All right, now that therefore you get onto the actual speed. Now author wanted you to get this relationship in mind. That's ideal. Say actual speed, what is that actually it is traveling with? Depends upon how many wagons did you attach to this. That's what the point here is. How many wagons did you attach? I said that this is the maximum speed. Maximum speed or the ideal speed is nothing but 60. All right, that's a maximum. All right, now that's a maximum speed or the ideal speed. Great. All right, now let's substitute. You already know the SR value here. From here you can say that SR is equal to K times of root W. Can I write it like this? Of course, yes. Well, it K times of root W. Substitute here. Therefore, SA is equal to ideal. Actual speed is equal to ideal speed. Let me substitute the ideal speed here, friends. What is that? 60. Ideal speed minus K times of root W. K times of root W. Now, this is the master relationship I get. This is the master relationship. After reading this, you understand that, man, this is the master relationship. Hey, what is the first case here, friends? Put the first case to perspective here. What is the first case? When there are 4 wagons attached, the train, or the speed of the train is reduced to 54 kilometers. When 4 wagons are attached, the speed now got reduced to, which means now it is traveling with a speed of 54 kilometers. Great. Apply this here. 54 is equal to, therefore 54 is equal to 60 minus K into what? Root 4. Let root 4. Solve this. Let's solve this here. Therefore, you will say that, okay, root 2K is equal to, therefore 2K is equal to, 2K is equal to 6. 2K is equal to 6. Therefore, K is equal to 3. Perfect. Now, so therefore, you got the value of K is equal to 3. If you got the value of K is equal to 3, can I rewrite this? You can rewrite. Okay, all that is not required. From explanation perspective, I'm rewriting. That's it. Therefore, you will say that actual speed is nothing but 60 minus the value of K is known to us. The value of K is known to us, which is nothing but 3. Therefore, you will say that 3 times of root W. I can write it like this. Actual speed, now I can write it because I got to understand the value of K from here. Fair enough. Now, therefore, let's go to the question. What is author's question? Having said this, now he's saying that find the maximum number of wagons that can be attached such that the speed should not fall below 30 kilometers per hour. So what is that author is trying to say? Author is trying to say that, man, look, the actual speed should not fall below 30 means what? The actual speed should be greater than or equal to 30. It should not fall below 30 means what? Up to 30 I am fine. Don't make this vehicle move below 30 kilometers per hour. Therefore he's saying that, okay, up to, all right, therefore speed of this actual speed should be what? Greater than or equal to 30. What is the actual speed? Substitute, friends. Substitute. Actual speed I'm underlining here 60 minus, therefore substitute here 60 minus 3 times of root W is greater than or equal to 30. All right, now divide throughout by 3. Therefore, you will say that 20 minus root W is greater than or equal to 10. All right, that's what you write there. Therefore, root W is less than or equal to, just rearrange this proposition, just rearrange. Therefore, root W is less than or equal to 10. All right, less than or equal to 10. Root W is less than or equal to 10. Square it on both the sides. Therefore, W is less than or equal to 100. Less than or equal to 100 means what? W can be 0 also, W can be 1 also. But what did author say? Can you tell me the maximum? You will say that maximum is 100. All right, maximum is 100 because don't attach wagon. That's also fine. But you said that, all right, now the speed should not fall below 30. Therefore, what? You can attach up to W max. Therefore, what is the max you can attach? The max you can attach is 100. Beautiful question. Beautiful cat question it is. Right? Yeah. So here we go. Already I made you understand certain concepts of ratios, I spent about 1 hour on that. Then I spent 30 minutes on proportion. Then I spent about 30-40 minutes on the relationships as well. All right, that's a direct variations, where direct variation, inverse variation, then the compound variation or direct relation, and inverse relation. Right, put them together. All right, now this forms the basic of this. Now whatever the content, whatever the material that you guys have, please go ahead right now, use it to your advantage. As I keep telling you, when I speak, all right, now when I am solving it, it looks good, but when you start solving it, that is when the skill get built. All right, therefore go ahead, all right, take about 2-3 dozens examples on this. All right, solve at least about 40 to 50 questions, so that all right, you kind of all right, now that kinds of builds the required skill as well as speed. The both clarity and speed comes once you solve somewhere between 30 to 50 odd questions of various difficulty levels. Here we go. I stop the lecture here. Tata, bye bye. See you in my next lecture. Bye till then. Stay blessed.